Beloved learners, names of topics with exact duration is mentioned in the description box. On desktop and laptop, description box is just below the channel name. On smartphones, description box is just above the channel name. Above channel name, you can see views and uploading time, and just beside uploading time you can see some dots and more, like this red more. Okay, there will be dots and more written. Please tap or click on the word more and you will find details of the video. If you want to get any maths question of IGCSE O and A level solved, please send me the question number and paper code through WhatsApp. I will do the needful. My WhatsApp number is 880 1711 319 456. Thank you all. So let's move on to the topics of probability and statistics 1. Our first topic of the solution is motion laws, application of motion laws. And you know, motion law means the laws of the Newton, motion laws of Newton. And for solving and application of this law, first question has been selected from paper 9709/43 for the session May June 25, and question number 5 belongs to the mentioned topic. Let's read it. A van of mass 2500 kg traveling at speed v meter per second experiences a resistance force of k v square Newton. The constant power of the van's engine is 62.5 kilowatt. The steady speed that the van can maintain when moving along a straight horizontal road is 50 meter per second. So that k is equal to 0.5, and find the acceleration of the van when its speed is 25 meter per second on this straight horizontal road. So all of us know what the Newtonian motion laws are. That is simply the direction is, look at this, the van is traveling at a horizontal road, look at this, along a straight horizontal road, so direction is just horizontal. Okay, and the motion law, we know that it is nothing but driving force minus resistance to motion must be equivalent to the product of mass and acceleration. And driving force is equal to, we know driving force of an engine is actually power over velocity, power divided by velocity, minus resistance to motion is already given. Look at this, they have written there is a resistance force of kv square. This is our resistance to motion, so kv squared. And what's the state of speed? It is moving at a constant speed. As the speed is constant, there is no acceleration at all. That means right side is 0. And power is given, how much is the power? Power is given 62.5 kilowatt. This is our power. So 62.5 means 62,500. So let us write 62,500 watt over velocity is written over here. It is 50 meter per second when it was moving at a constant speed, divided by 50, and velocity is 50, so 50 squared k is equal to 0. Now if we isolate our k, then it is going to be, if 62,500 is divided by 5, it is 50, it is going to be 1250. So 2500 k is equal to 1250. Hence if we dissolve these numbers, it is going to be k is equal to 0.5, and they have told us to show that, so we have showed. Well, Let's move on to the next part. This is not all of the solutions. It's actually they have told to find the acceleration of the van when its speed is 25 meter per second. So for acceleration, the concept will remain same, that Newtonian motion laws, but the quantities may be different because at this time it is no more constant speed. So let us apply the same concept. The concept is motion law of Newton, and direction is also same. The van is moving in a horizontal direction. The concept is a driving force minus resistance to motion is equal to mass into acceleration. Driving force, we have already come to know, driving force means power divided by velocity minus resistance to motion. Okay, resistance to motion is kv square. K has been obtained as 5, and then v square is equal to mass of the car was 2500, and they have told us to find acceleration. No, so let it remain unchanged. Now power is 62,500. We have already used 62,500, and velocity at this stage, velocity is different. Look at this. Initially they told that velocity was 50, but now velocity has become 25 meter per second. This is our velocity. So let us write 25 minus zero point 0.5 into velocity is 25 squared. 25 squared is equal to 2500 A. Or if we simplify the left side, it is going to be 2500 minus 2500 minus 3000 312. 312.5 is equal to 2500 A. Hence our A is going to be, denominator is 2500, and numerator is, if we subtract 312.5 from 2500, it is going to be 2187 and finally our acceleration is going to be 0.87. Oh, it is a round figure. No, this is not rounded figure, this is exact figure. So let us write 0.875 meter per second square is the acceleration when velocity was 31 meter per second. So that's all about the solution to the first question. Let's move on to the immediate next part of this question. Question number B, which has been printed on the next page. It says the van begins to ascend a hill inclined at an angle theta degree to the horizontal. That means the van is no more moving on a horizontal road. The van travels along a line of greatest slope of the hill. The speed of the van at the start of the hill is 20 meter per second. And its acceleration is 5 meter per second square. Later, on the same hill, the speed of the van is 30 meter per second and its acceleration is a meter per second square. The power of the van's engine remains 62.5 kilowatt and the resistance to motion is also zero point 0.5 V square Newton. Find the value of alpha or acceleration and the value of theta. So let us apply the same concept, and direction is now different. It is just moving on an inclined hill. So the concept we have been applying is driving force minus resistance to motion is equal to mass into acceleration. So driving force is, let me show you through a diagram. So this is the van and this is normal reaction, this is weight. Yes, this is the diagram, and the van is moving upward on the inclined mountain. Well, then our driving force is the same formula. Concept is power over velocity minus resistance to motion is also unchanged, which is zero point 0.5 v square, zero point 0.5 v squared equal to mass into acceleration. Okay, acceleration is to be obtained and mass is 2500. So then, but we should not ignore another concept. Look at this here, weight is also causing a resistance to motion, so we should not ignore weight, which is mass into mg sine theta, mg sine theta. Remember, weight should not be ignored because weight is a kind of force. In this case, this is resistance force. Then right side is 2500, 2500 A. A is acceleration. Now power is same 62.5, so 62500. And velocity in the first case, look at this first case, velocity was 20 meter per second. So let us write 20 minus zero point 0.5 into 20 squared, 20 squared minus mass of the car is 2500 and acceleration due to gravity is 10. So this is going to be 25,000 sine theta. Sine theta is equal to 2500 A. We have already made a mistake in the second step. Look at this, acceleration is given 5a, so acceleration is not a, it is 5a. Now if we multiply 12,500 by 5, it is going to be 12,000 2,500 multiplies by 5, it's 12,500 a, 500 a. Then on the left side, if we simplify this, it is going to be 3125, 3125 minus 200, 400, half of 400 is 200 minus 2500, 25,000. It should not be 100, it is 1000. 25,000 sine theta, 25,000 sine theta equal to 12.5 thousand A, 12,500 A. Then if we isolate our sine theta, then we can form an equation, and we'll have to form two equations. Remember, as there are two values to be obtained, so there must be two simultaneous equations. Or our sine theta is going to be, if we isolate sine theta is going to be 2500. All the symbols should be simplified, then it is going to be 2925, 2925 minus 12,500 A, 12,500 A over 25,000. 25,000, we have dissolved the symbols. Please don't get confused. 12,000, 2,000, 25,000. And this is equation number 1. Then, as the direction is same, we are going to apply the same concept with the same direction. For the second phase of the journey, it is still now it is moving in the same direction, that means traveling on the inclined mountain. So our concept is also same, driving force minus resistance to motion is equal to mass into acceleration. And driving force here is power over velocity minus resistance to motion is also same, 0.5 v squared minus mg sine theta. That means weight is also causing resistance to motion. Mg sine theta is equal to 2500, is mass is 2500. And our acceleration, let us see what is the acceleration in the second phase. In the second phase, look at this, acceleration velocity is 30 meter per second, acceleration is a, so it is going to be simply 2500 a, 2500 a. Well, Then let us substitute the values. Power is 62,500 and we have already seen velocity is 30 meter per second. 0.5 into 30 squared minus mg sin theta is 25,000 sin theta. We have already written it in the previous part. 25,000 sin theta equal to 2500a. After simplification we will get 20833.3. If we divide this 208 3.33 minus 450, half of 900 is 450, minus 25,000 sine theta equal to 2500 into acceleration. 2500 into acceleration. Well, if we isolate our sine theta again, it is going to be resolving the symbols. It is going to be 2500, I mean 16.33. If we subtract 450 from 2083, it is going to be 1633 minus 33.33. We should not ignore the fraction. 33 minus 2500 into acceleration. 2500 into acceleration over 25,000, and that may be equation number 2. And if we observe both the equation, left sides are sine theta. Okay, on both cases left side is sine theta. Here, since left sides are sine theta, so surely the right side will also be equal. Okay, so let us write from equation from if we subtract equation 2 from equation 1, it is going to be, let me find some space on the right side. I think I can continue. Okay, our equation 1 is 2925 minus 12,500a over 25,000. Let it be written on one side. 2925 minus 12,500 a over 25,000 equal to the right side of the other equation is 1633.33 minus 2500 a over 25,000. So let us substitute this. 1633.33 minus 2500a 2500a over 12,500, sorry, 25,000. It is 25,000. So from both sides, if we multiply both sides by 25,000, it is going to be just 12,500 negative 12,500a, then plus 2,500a. Then if we subtract 2925 from 1633.33, it is going to be negative 1291. Okay, 1291, 1291.67. And on the left side, if we do subtraction, it is going to be just 10,000. 10,000 into acceleration is equal to 1291.67. So if we divide both sides by 10,000, it is going to be, acceleration is going to be 0.129167. If we round it up to three significant figures, it may be 0.129 meter per second squared. Okay, meter per second squared, that is the value of acceleration A. Now we are going to find the second value, that means the value of theta. Hence our theta is going to be, hence theta is going to be, any of the equation can be picked up. If we pick up the first equation, it is going to be 2925 minus 1200 12,500 into 0.129167 divided by 25,000. So our theta is going to be, if we transpose sine to the other side, it is going to be sine inverse of 2925 minus 12,500 into our acceleration 0.12916. Remember, we will have to take some more digits after decimal point for more accurate answer. Then our theta is going to be only 3.00 degree. 3.0 degree. So our answers are, what are our answers? The theta is 3.0 degree, where acceleration is 0.129 meter per second square. So that's all about this question. Now let's move on to the other question under the same topic. The immediate next question has been selected from paper 9709/45 for the session May June 25, and question number 2 belongs to the motion law, concept of the motion law of Newton. Let's read it. A machine for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of the nail. The mass of the hammerhead is 1.5 kg and the mass of the nail is 0.005 kg. The hammerhead hits the nail with speed 32 meter per second and remains in contact with the nail after the impact. Calculate the speed with which the combined hammerhead and nail move immediately after the impact. Give your answer correct to three decimal places. So, though our topic is motion law of Newton, as this part of this question related to our concept, mentioned concept, that's why we will have to solve this. For finding the velocity, look at this, they have told us to find the speed of velocity. For velocity after collision, we apply the conservation of momentum. Though it belongs to different topic, we will have to solve this, because extracted information, the information we will extract from this will be used later on. So let us apply the conservation of momentum. Conservation of momentum is mh, that is mass of hammerhead into initial velocity of hammerhead plus mass of the nail into initial velocity of the nail is equal to mass of the hammer into velocity after the collision, velocity of hammer after the collision, and mass of nail as well as into velocity of the nail after collision or after hitting. So the mass of the hammerhead or hammer is 1.5, 1.5, 1.5, and initial velocity of hammerhead is given as 32 meter per second. 32 meter per second plus nail, about nail it was 0, actually it was at rest. Okay, so mass of nail is 0.005 into 0 because the nail was at rest before the collision or before the hitting. And after the collision, mass will remain same as it is 1.5, and velocity is to be obtained, and mass of particle in, I mean nail, is 0.005 and velocity is to be obtained. If we simplify our statement, then it is going to be 48 is equal to 1.5 plus 0.005 is actually 1.505. 1.505 V. 1.5, because after collision both the hammerhead and the nail were in contact with each other. That's why the velocity will remain same. Hence velocity after the impact is going to be 31.894 meter per second. Well, and if we round it up to three significant words, I think they have told us to write three decimal places. That's why we have written 894 after decimal fraction. Then let's see what B says. B says there is a constant force resisting the motion of the magnitude 25,000 Newton. Calculate the distance the nail is driven into the wood. So for distance, always we opt for the Shubert formula. It belongs to kinematic. But before that, Shubert formula always requires acceleration. So let us find the constant acceleration. And for acceleration, always we apply the concept of the motion law. So the direction of the nail and hammerhead is down, vertically downward, and our concept is driving force minus resistance force is equal to mass into acceleration. Let us see what is the driving force actually. What is the external force? Hammerhead and the nail, actually they are, hammerhead is hitting the nail vertically downward. There is no other forces acting on hammerhead except the weight. Okay, so we will have to write mg, driving force is mg sine 90 degree. Sine, you may please don't get confused. We are not ignoring the weight. You cannot ignore the angle also. So minus resistance to motion is given 25,000 equal to mass of hammerhead and nail. It is 5.00, sorry, 1.505. Let me show you. It is 1.5 was the mass of the hammerhead and 0.005 is the mass of the nail. So it is together because they have remained in contact with each other. So total mass is 1.505 into acceleration. Well, so mass of both of them combined, it is 1.505 into sine 90 is 1. Okay, and acceleration due to gravity is 10 minus 25,000 equal to 1.505 into acceleration. If we isolate our a, means acceleration, it is going to be negative 24,984, 24,984.95 over 1.505. 1.505. Okay, then our acceleration is going to be 16. It must be negative 16,601.25 29568. 29568. We have taken some more digits after the decimal point than it is necessary so that we get more accurate answer. So our acceleration after the impact is negative 1600, sorry, 16,601.29568 meter per second square. Now we will find our the distance. They have told us to find the distance, and for distance we will apply the Schubert formula, which is v square is equal to, we know v square equal to u square minus u square plus 2as. Okay, now changing the color, so v square is equal to u square plus 2as is the concept we are going to apply to find. S stands for displacement, and final velocity was definitely zero. Look at this, when the nail was hit by the hammerhead, finally it got stuck. That means the final velocity was zero. And let us see the initial velocity also. Initial velocity has been already obtained. We have found after hitting the nail, the immediately after that the initial velocity was 31.894 meter per second. So let us substitute all of these values. Initial velocity, final velocity is 0. Initial velocity was 31.894 squared, and our acceleration is, look at this, this is deceleration, means negative acceleration, so we will have to use negative symbol. Let us use negative symbol. Negative 2 into acceleration is 1660101.29568. 2 into s. Now if we isolate our s, it is going to be, it is going to be 31831.894 square, 31.894 square over 2 into 16,601.1.29568. 29568 and 8. So finally our displacement is going to be 0.0306, 0.030306, if we round it up to three significant figures, okay, or three decimal places. So that is what the final displacement which has been traveled, distance traveled by the nail after hitting by the hammerhead. Now let's move on to one more question. This is not meter per second, sorry, it is a displacement, so let it be written as only meter. So displacement or distance is 0.0306 meter. Let's see the next question. The immediate next question has been selected also from the same paper, I mean 9709 slash 45 for the session mentioned 25, and question number 5 belongs to our discussable topics. It says a car of mass 1500 kg is traveling along a horizontal road. Look at this, this is along a straight horizontal road. It is given that there is a constant resistance to motion. The engine of the car is working at 24 kilowatt while the car is traveling at a constant speed of 32 meter per second. The power is now increased to 28 kilowatt. Find the acceleration of the car at the instant it is traveling at a speed of 36 meter per second. So we are going to apply the same concept, and the direction is actually horizontal, straight horizontal direction. Concept we have been applying is driving force minus resistance to motion is equal to mass into acceleration. Okay, and what is the driving force? The formula we have been applying is power over velocity, and resistance to motion is Look at this. Resistance to motion is given somewhere, or it has been constant resistance to motion. Resistance to motion is not given, remember. So we will have to find it. That is frictional force. Okay, resistance to motion means here frictional force. So for frictional force, at the same time one more force may be ignored. Sometimes you get confused that sometimes we calculate and consider weight, sometimes we don't. Actually every time we calculate and consider weight. Let's see how. It is mg cos 90 degree. Okay, because this is horizontally straight, equal to, so sometimes some teachers may not write this weight, it may remains invisible, but definitely it plays a role, and this is the component of the concept of motion law of Newton. So please don't get confused that sometimes we are to use weight or apply weight, sometimes we are not. Actually that is not the fact. Fact is every time we use the weight, sometimes it is as driving force, sometimes as frictional force or resistance force, not frictional, resistance to motion. So this time we are using as resistance to motion. And mass into acceleration is zero because it is traveling at a constant speed. Look at this, constant speed, so it is zero. Then power is given 24,000, 24 kilowatts, so 24,000, and velocity is 32, minus frictional force is to be obtained, equal to frictional force, and cos 90 is 0. So adding and subtracting 0 causes no change to the quantity. So our frictional force is, if we divide 240,000 by 32, sorry, 24,000 by 32, this is our frictional force is 750 Newton. Well, whenever we find our frictional force, now easily we can find our acceleration as well. So direction is same, still the car is moving on a horizontal straight road, and the concept is also as usual same, driving force minus resistance to motion is equal to mass into acceleration. Well, so driving force is P over V, power over velocity. Power is, power is, how much is the power? Power is 28,000 this time. I am going to show you 28,000, and velocity is 36. Minus frictional force we have just found 750, and if you question about the weight, we are writing mg or sorry cos 90 degree is equal to mass into acceleration. Mass of the car is 1500 kg, so it is going to be 1500 into acceleration. Well, let me show you where we have got this 28,000 and 36. Look at this. In the second phase of the journey, the power is 28,000, 28 kilowatt, and velocity was 36. They have told when the velocity was 36 meter per second, find the acceleration. Okay, that's why we have used 28,000 instead of 24,000, and 36 as velocity instead of 32. If we calculate this, we are going to find 1500 A is equal to, everywhere there is a zero. Okay, so this zero can be dissolved from everywhere. So 150A is equal to, this is also zero. Okay, 150A is equal to 28,000, 2800 over 36 minus 750, I mean 75. 75. If we isolate our A is going to be 2800, 2800 over 36 into 150, 50 minus 75 over 150. Hence, finally, our acceleration is going to be, using our calculator, we are going to find it 0.0185. 0.0185 meter per second squared. So this is our final answer to this question. They have told us to find acceleration, and surely for finding acceleration we choose the concept of the motion law of Newton, and we did so. Finally, our answer is 0.0185 meter per second square if we round it up to three significant figures. Let's see the next question. The next question is printed on the next page. It says, it is given instead that the resistance to the motion of the car is 340 plus 4 V Newton when the speed of the car is V meter per second. When the engine is working at 20 kilowatt, the car is traveling at a constant speed. Find the constant speed. So concept is same, and it is still moving on the straight horizontal road. So it is driving force. Our concept is driving force minus resistance to motion is equal to mass into acceleration. So driving force is power over velocity minus resistance to motion has already been fixed, which is 340 plus V. And if you talk about weight, we are going to write mg cos 90 degree because it is traveling on a straight horizontal road, equal to 0 because the car is traveling at a constant speed. Well, so power is, in this case, power is what? 20,000. So 20,000, and velocity is to be obtained. Velocity is to be obtained minus 340 minus V equal to 0. Well, then if we multiply every quantity by V, it is going to be negative V squared minus 340 V plus 20,000 plus 20,000 equals to 0. We will have to factorize this, and for factorizing, let us dissolve the symbols of V squared. Sorry, we skipped something. It is not 340 plus V, it is actually 340 plus 4V. 4V. So it is 4V. If it is 4V, then it is going to be negative 4V square. So 4V square by negative 4, if we dissolve every quantity, it is going to be plus 485 years. 485 is 340, so plus 85 V, and minus, if we divide 20,000 by 5, it is going to be 5,000. Now if we break up the middle term, it is going to be V square plus 125 V, 125 V minus 40 V minus the final quantity constant number 5,000 is equal to 0. Is equal to 0. If we resolve it into factors, it is going to be V plus 125, and the other factor is going to be V minus 40 equal to 0. We cannot accept the first factor because our velocity is speed here. Speed can never be negative. Hence, our velocity is going to be V is equal to 40 meter per second. Okay. Since if you want to reject, you can show a cause since V is greater than 0 because it is speed. Speed can never be negative. Okay. So let's see the next question. Since there is no more question left under the topic of motion law of Newton for the session, summer session 25, so we are moving on to the next topic. Our second topic is finding frictional coefficient, and under this topic we have chosen the question paper 9709/42 for the session May June 25. And to find the frictional coefficient, question number 5 of this paper has been selected. So let's go through question number 5. One end of a light inextensible string is attached to a particle of A of mass 3 kg. The other end of the string is attached to a particle of B of mass 4 kg. Particle A is in contact with the rough plane inclined at 30 degrees to the horizontal, and particle B is in contact with the smooth horizontal plane. A second light inextensible string is attached to B. The other end of this second string is attached to a particle C of mass 5 kg which hangs vertically. Both strings are taut and pass over small smooth pulleys that are fixed at the ends of the horizontal plane. The part of the string from A to the pulley is parallel to the line of greatest slope of the inclined plane, and A, B, and C are in the same vertical plane. The system is released from rest. In the subsequent motion, C moves vertically downwards with acceleration 2 meter per second square, and neither A nor B reach pulley. Find the tension in each of the strings. So finding tension belongs to the other topic. We have solved it in another topic. Our topic is finding frictional coefficient, and that may be the question number B. Question number B says find the coefficient of friction between A and the inclined plane. So it is about A and inclined plane. Well, for finding frictional coefficient, first of all we will have to find the normal reaction force, because if we read the question again, we will find that the plane A is rough. It is written with here. They have told us to find the frictional coefficient between particle A and the plane, but the particle A is in contact with a rough plane. So whenever there is a rough plane, first of all we will have to find the frictional coefficient. So let us start our solution, and for finding frictional coefficient we will draw a diagram with the system. Let me draw the diagram. This is the normal reaction and this is weight. This is the diagram of particle A, and whenever the system is released, particle A was moving upward. That was the direction. Well, let us find first our normal reaction. So for our normal reaction we know that R plus, there is no upward force acting on particle A, so it is 0, equal to downward force is mg cos 30 degree, cos 30 degree. Well, or R is equal to mass of particle A is 3 kg, and acceleration due to gravity is 10, and cos 30 is actually square root over 3 over 2, square root over 3 over 2. Hence our normal reaction is actually, finally normal reaction is 15 square root over 3, 15 square root over 3 hours is our normal reaction. So we have already obtained the normal reaction force. Then simply we can apply the concept of the motion law of Newton. That means driving force minus frictional force, or resistance to motion is equal to mass into acceleration. And before that, as there are two tensions, I mean two strings included here, so we should know the tension acting in the string AB, which has already been obtained in solution number A. So let's write from A, from A, tension in the string AB, tension in string AB is 32, equal to 32 Newton. Well, we do have all supporting information. Now we can start our solution. So let us write the concept we are going to apply. Our concept is the most widely used concept in physics is the motion law of Newton, second law of Newton, that is driving force minus resistance to motion is equal to mass into acceleration. Well, so driving force is nothing but the tension in the string AB, because A was moving upward, and here only tension in the string AB is causing it move upward. So driving force is tension in the string AB, tension in string AB. And resistance to motion, there are two resistance to motion. One is weight is trying to move it downward, so weight is also one of the resistance to motion, which is mg sine 30 degree. And another one is frictional force, and frictional force is mu into normal reaction force equal to mass into acceleration. Mass of the particle is 3, acceleration is given 2 meter per second square. Here it is given acceleration is 2 meter per second square. Now if we substitute the values, we do have tension in the string AB is 32. From question solution number A, we have got this 32. And mass into acceleration, mass of particle is 3, and acceleration due to gravity is 10, and sin theta is zero point 0.5. Sin 30 is 0 0.5 minus mu. Mu is to be obtained, means frictional coefficient. So we will have to write R has already been obtained, which is 15 square root over 3 into R equal to 6. Well, then if we isolate mu, sorry, this is not R, it should be mu. If we isolate mu, it is going to be square root of 15 square root over 3 mu is equal to 32 minus 15 is 17. So 17 minus 6. 17 minus 6. Hence our mu is equal to 11. 17 minus 6 is 11. 11 will be divided by 15 square root over 3. 15 square root over 3. Then if we divide 11 by 15 square root over 3, it is going to be 0.423. 0.423. So our frictional coefficient mu is equal to 0.423, and mu is the frictional coefficient between the plane and the particle A. Well, now we are moving on to the next topic, resolving forces. And the first question under this topic has been selected from paper 9709/41 for the session May June 25. We are solving the very first question of this paper. The question is, a block of mass 12 kg is being pulled by a rope up a rough plane. The plane is inclined at an angle of 20 degrees above the horizontal. The rope pulling the block is parallel to a line of greatest slope of the plane. The coefficient of friction between the block and the plane is 0.4. The acceleration of the block is 2 meter per second. Find the tension in the rope. So as the surface is rough, look at this, the plane is rough. So first of all, we will have to find the normal reaction force. Before that, let's draw a diagram of the scenario of the system. So this is the system diagram. Now first of all, we'll have to find the normal reaction force. So normal reaction force, if we calculate, is R plus, there is no upward force, downward force is nothing but weight, mg cos 20 degree, cos 20 degree, mg cos 20 degree. Hence our R is going to be, mass of the block is 12 kg. So 12 into 10, 12 into 10, and cos 20 degree, 12 into 10 cos 20 degree, cos 20 degree. Hence our normal reaction is going to be 120 cos 20 degree, 120 cos 20 degree. Well, so let us resolve the forces, and for resolving the forces vertically and horizontally, we always apply the concept of the motion law of Newton, second law of Newton, which is driving force minus resistance to motion is equal to mass into acceleration. So let us apply the same concept. So our concept is driving force, it is sliding up. So concept is driving force minus resistance to motion is equal to mass into acceleration. Okay, so driving force is the tension, the rope, actually rope is pulling the box upward, rope is pulling, this is the rope. So the driving force is nothing but the tension in the rope, minus there is a constant frictional force which is mu r. Because the plane is rough, we should not avoid or ignore the frictional force caused by the plane. Then minus weight is the other frictional force or resistance to motion. So weight is mg sine 20 degree, sine 20 degree, equal to mass of the block is 12 kg, and acceleration is given 2 meter per second. Here it is given acceleration is 2 meter per second. So if we resolve the forces, in the next step, substituting the values, we will get tension minus mu, frictional coefficient is given 4.4. So 0.4, and we have already found the normal reaction force R. R is 120 cos 20 degree, cos 20 degree, minus mass of the block is 12, acceleration due to gravity is 10, and then sine 20 degree, sine 20 degree equal to the right side, and right side is 24, equal to 24. Now if we isolate t as the subject, then t is equal to, or t is equal to 24 plus, it is going to be 4, that is 48 cos 20, 48 cos 20 degree, 48 cos 20 minus, sorry, not minus, plus 120 sine 20, 120 sine 20 degree, sine 20 degree. Now using our calculator, we will find that, using our calculator, we can see that tension acting in the rope is 110 Newton, 110 Newton. So that is our answer to the final part of the solution. Okay, they have told us to find the tension in the rope, which is 110 Newton. So let's see the next question. Next question also belongs to the same paper. That means paper 41 for the session May-June 25. And question number 4 has been selected as the next question. Let's see what it says. It says a lorry of mass 18,000 kg is traveling along a straight road. On a horizontal section of the road, the power of the lorry's engine is constant. There is a constant resistance to motion of 1600 Newton. The steady speed which the lorry can maintain with the engine working at power P watt is 30 meter per second. Find the value of P. So it's a very simple actually. If we resolve the forces horizontally, let us show the direction. It is driving force minus resistance to motion. Driving force minus resistance to motion is mass into acceleration. Now let's see what is the driving force here. Driving force is equal to we know power over velocity minus frictional force is constant. Look at this. It is written that 1600 Newton is the frictional force equal to mass into acceleration as the lorry is traveling at a constant speed, so there is no acceleration at all. That means it's zero. Or P over V, velocity is already given, which is 30 meter per second. So P over 30 is equal to 1600. Hence our power is going to be P is equal to, let me write just beside that. If we multiply 1600 by 30, it is going to be 48,000. So 48,000 watt is our power for this steady speed. Let's see the next question. Next question says, at an instant when the speed of the lorry is 16 meter per second, its engine is working at a power of 40 kilowatt. Find the acceleration of the lorry at this instant. So at this time, there is acceleration. Our concept is exactly same. The second law of motion and direction is also same. So driving force, our concept is driving force minus resistance to motion is equal to always mass into acceleration. So what is the driving force? Driving force is P over V, power over velocity, minus resistance to motion is also constant. It has been used, we have already used it, 1600. 1600 is equal to mass into acceleration. Okay, mass of the lorry is 18,000. Let us see, mass of the lorry is 18,000, so it is 18,000 alpha, or acceleration 18,000 into a. Now the velocity of the lorry is 16, so P over, and power is also given here. Look at this, it is working at a power of 40 kilowatt. 40 kilowatt means 40,000, and velocity is given 16. So if we divide by 16, minus 1600 is equal to 18,000 into acceleration. Okay, we are supposed to find acceleration. So acceleration is going to be, if we divide 4,000 by 16, it is going to be, denominator is going to be 18,000, and numerator is, uh, let's divide 4,000 by 16, not 4, it is 40,000, sorry. If we divide 40,000 by 60, it is 2500. So 2500 minus 1600, that is 900. 900. So if we divide 9 by 180, it is going to be 0.05 meter per second square. This is exact value. So finally our acceleration is 0.05 meter per second square. Let's see what B says. Question number B says, when the lorry has reached a speed of 20 meter per second, it begins to ascend a section of road inclined at an angle alpha to the horizontal. The engine now works at a power of 120 kilowatt. There is no change in the lorry's speed as it ascends the hill. The constant resistance to motion remains 1600 Newton. Find the value of alpha. So our concept is same. We are not deviating from the same concept. So this is the diagram for this system. So let us write our concept now. The direction is, it is sliding up on an inclined plane. Okay, that means it is moving on an inclined plane. So our concept is driving force minus resistance to motion is equal to mass into acceleration. Okay, or what is our driving force? The same concept as we have been applying, it is power over velocity minus resistance to motion is 1600. That means frictional force is 1600. But one more force is causing resistance to motion, which is weight. We cannot avoid weight, which is mg sine alpha is equal to mass into acceleration. Mass into acceleration is 0. Now you may ask a question, how can it be, how can there be no acceleration? Look, it is it is written there is no change in the lorry speed as it ascends the hill. That means there it is always at constant speed, means there is no acceleration. Now if we substitute the values, our power is given 120 kilowatt. So 120,000 over velocity is to be obtained. Sorry, velocity is also given. Velocity is 20 meter per second. So 20 meter per second minus 1600, and mass of the lorry is 18,000, and acceleration due to gravity is 10, so it is 180,000. 180,000 sine alpha. Sine alpha is already given here. No, sine alpha is not given, so we will leave it unchanged. Sine alpha is equal to 0. Or if we isolate this 180,000 sine alpha is equal to, now 1600, it is, sorry, in front of this there is a negative symbol. Then if we divide this 12,000 by 20, let one of the zeros be dissolved, so 600. So 600 minus 1600, that is 1000. So it is going to be negative 1000. Well, then our alpha is going to be, or it is not 1000. So from 120,000, if we divide, it is going to be 6,000. From 6,000, if we subtract 1600, it is going to be 4400. Okay, hence our acceleration, I mean alpha is going to be sine inverse of so if both of the zeros are dissolved, it is going to be 44 over 800. 800 is equal to. So using our calculator, we find that angle is sine inverse of 44 over 1800 equal to 1.40 degree. So that is what the final answer to this one. That means the angle is 1.40 degree. Well, Then let's move on to the next question. The next question has been selected from paper 9709/42 for the session May June 25. And question number one, the first question belongs to forces. So let us solve this one. The question says a crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 Newton. Inclined at 20 degrees above the horizontal, the crate moves a distance of 12 meters in 8 seconds with constant speed. Find the constant speed of the crate. So let us draw a diagram of the system. The diagram may look, this is the horizontal surface. So this can be the diagram of the system. Then they have told us to find the velocity, I mean speed. So we know velocity is equal to distance over time. Distance over distance divided by time. So what is the distance? Distance is 12 meter. Distance over time taken. Time taken equal to distance is 12 meter and it took 8 minutes. Okay, so equal to 12 meter over 8 seconds, sorry, not minutes, 8 seconds. So our velocity is equal to, velocity is 1.5 meter per second. Let's see the next question. The next question says find the work done by the 25 Newton force. Here there is a little twist, so let us solve this one first. Work done by, work done, work done, we know the formula is work done is equal to force into displacement, or force into distance. Okay, force into distance. Now the twist is, you may get confused that the force is given 25 Newton, but the twist is, look, they told that force is acting 20 degree above the horizontal. Look at this. It is force of magnitude 25 Newton is inclined at 20 degree above the horizontal. So it is not 25 degree. It is 25 cos 20 degree. So this is the twist. Please don't get confused with this. So force is not 25. It is actually, because 25 means if it is horizontal. Suppose if it is written that horizontal magnitude is 25, then you can suppose that it is horizontal axis. Okay, or that is force, horizontal force. But they have told it is 25 Newton inclined at 20 degrees, so the force is 25. So for horizontal, if we calculate horizontally, it is 25, this one. So this one is 25 cos 20 degree. I think you got my point. Into distance is 12 meter. So finally the work done by the force is 25 cos 20 into 12 is 281, 281.90779. If we round it up to three significant figures, it may be 282 joule. 282 joule is the work done by this force. Then the next question says find the power at which 25 Newton force is working. So power is equal to, we know the third concept, power formula. Power is equal to work done divided by time taken. So it is work done over time taken. Already we have found that work done by this power was, by this force was what? 281.90, 281.90, 779 over time taken. How much, how many seconds were taken? 8 seconds. So our power is going to be, if we use our calculator, it is going to be 35.2, 35.2 Newton, 35.2 watts. Okay, so this is what the answer to all of these question, all of the parts of this question, and it's very simple, the fundamental concept of kinematics. Let's see the next question. The next question has been selected from paper 9709/43 for the session May June 25, and we are going to solve question number 4. Let's see what it says. Three blocks P, Q, and R of masses 25 kg, 20 kg, and m kg respectively are held in equilibrium by three light inextensible strings OP, OQ, and QR. OR. The strings OP and OR both pass over small fixed smooth pulleys A and B respectively, with P and R hanging vertically below the pulleys. The block Q hangs vertically below the point O. The angle between OA and the vertical is 30 degree, and the angle BOQ is equal to a degree. Find the value of M and the value of alpha. Look, this is the most challenging question of this paper, so we should be very careful while solving this question. Before the solution, let me complete the diagram. Okay, this is the completion of the diagram. So as I have already mentioned that this is the most complicated and challenging question of this paper. So in this case, first of all, as there are three strings, so which one, or three blocks, which one should be our standard, I mean parameter? First we will start with this one. Okay, and this is driving force for this horizontally, and this is the left onward is our negative force or frictional force or whatever you tell, and this is the upward force as well as this is downward force. So Q is, we will start our solution using Q, which seems to be easier. So let us write for Q, for Q. Let us resolve the forces first horizontally. Okay, so for horizontally, what is the driving force? This is positive direction of x, so we will write mr, that means this one should be calculated. So mr cos, mr sin alpha, mr sin alpha, don't get confused. If you are confused, let me clarify this. Look at this, we are calculating this. Okay, horizontally we are resolving the force. So for this one, what is this force? This is actually tension in this string through which R is hanging. So this tension is what? This is mr, and all this tension is how much here? Tension is actually this one. The, this one is causing the tension, that is the tension force is on R is this. Okay, at O that positive force is only this one, so mrg sine alpha. Okay, now why is it sine alpha? Because look at this, if we calculate this horizon in term of this triangle, this is vertical line. Okay, that's why sine alpha. Okay, now now negative force. So negative force is this force, which is mg, mass of particle p, acceleration due to gravity, and that is not sine, it will be cos 60 degree, cos 60 degree is equal to 0, because the system is in equilibrium. Okay, so look at this. First we have calculated this direction. This direction is actually the tension. How much is the tension? Tension is actually nothing but the weight. So driving force is actually this tension along this string. Okay, tension force in this string, and this string is how much? It's actually mg, that means weight of r. So weight of r is mp, mass of particle p, into acceleration due to gravity cos 60 degree. I think you got my point. The driving force is to this direction of q, and resistance to motion of q is to negative direction. So for negative direction it is mpg cos 60, but for positive direction it is actually nothing but the weight. Okay, weight of box or block r. Then if we calculate this, mass of particle r is m, so acceleration due to gravity is 10, so 10 m sine alpha. Mass of particle p is 25 kg, so 25 into acceleration due to gravity is 10, and cos 60 is 0.5 equal to 0. If we isolate that value, it is going to be 10 m sine alpha is equal to 250. Half of 250 is 125. If we isolate sine alpha, hence sine alpha is equal to 125 over 10m, over 10m. We may leave this as equation number 1. There will be two simultaneous equations because we are supposed to find two values. So let us resolve the forces vertically. Okay, if we resolve the forces vertically applying the same concept, driving force minus resistance to motion is equal to, I think it's better I can change the color. If we resolve the forces vertically, so upward force is our driving force and downward force is our resistance force. Well, now let's see what is our upward force. Upward force is this one. Okay, as O is our center, so this is upward force. So for this upward force, what is this? The tension is actually weight of particle r, so it is going to be mp, sorry, it is actually lying below. Let me tell this is actually our reference frame. Is this is our reference frame. Okay, as this is our reference frame, so the first triangle is lying below the reference. Okay, this is our, suppose this is horizontal axis, so the first triangle having alpha angle, it is lying below the horizontal axis. So which one is positive? This one is positive. Okay, so for positive, what is our driving force? That is this tension, which is mpg sine mp, mass of particle p into g, and sine 60 degrees, sine 60 degree, then minus which angle is lying below the x-axis? This angle is lying below x-axis. Okay, so which is, how will we calculate this? Here tension is mrg cos alpha, mrg cos alpha, m r, mass of particle r, g, then cos alpha. Okay, and we are not ignoring the weight of q also. Look at this weight of q, that is also a downward force, which is m q sine 90 degree, m q G sine 90 degrees. Sine 90 degree. I think you got my point. Sine 90 degree. Sine 90 degree is equal to 0 because the system is in equilibrium. Equal to 0. Okay. So this is what the vertical forces. Once again, I am repeating this because you may get confused. So the first triangle, I mean, if you talk about this triangle is lying under the x-axis, whereas this triangle is lying above x-axis because our O is here. Okay, O is lying over here, so our x-axis is this. X-axis is the reference. So below the first triangle, I mean right side triangle, is acting downward, pulling the, that means the force is acting downward. These two, both of these are acting downward. Okay, these two objects or blocks. Only the final one is acting upward because it is lying above x-axis. So Q and R, these two blocks are acting downward. The force is acting downward, but P is, due to this pulley, though it is lying or hanging below, but according to this triangle or reference frame, it is actually acting upward. Okay, it is because it is the triangle lies above x-axis. So this is the positive value or driving force in terms of this scenario. Or if we substitute the values, it will show us. So mass of particle P is 25, 25. Acceleration due to gravity is 10, and sine 60 is square root over 3 over 2. Well, square root over 3 over 2. Minus mass of particle R or block R is mkg, and acceleration due to gravity is 10. So 10 cos alpha, 10 cos alpha, minus mass of particle Q, I mean mass of block Q is 20 kg. So it is 20 into acceleration due to gravity is 10, and sine 90 is 1. So it is 0. Now if we isolate our cos, it is going to be, let me see, can I write? No, there is no space to write at all. If we isolate 10m cos alpha, it is going to be, so 125 root over 3. So let us write 10m cos alpha is equal to, so it is 125 root over 3, 125 root over 3, 125 square root over 3 minus 20 into 10, that is 200. Root over 3 minus 200 minus 200. Now if we isolate cos alpha, hence cos alpha is equal to, cos alpha is equal to, numerator is going to be 125 minus 125 root over 3 minus 200 over, it will be divided by 10m, 10m. So this is our equation number 2. Okay. So already we have formed both of the equations. Now it's time to solve them simultaneously. Let me write just beside this over here. So what is our first equation? Let us write equation 1 divided by equation 2. So if we divide our equation 1 is sine alpha over cos alpha is equal to, then the right side is going to be 125 over 10m. 125 over 10m. 10m is the first equation. Then the second equation is 125 square root over 3 minus 200 over 10m or or sin alpha over cos alpha is equal to actually tan alpha. So tan alpha is equal to 10m and 10m, they can cancel each other. So it is 125 over 125 square root over 3 minus 200. 3 minus 200. Or our alpha is equal to, tan inverse of 125 over 125 root over 3, 125 root over 3 minus 200. Hence, our alpha is going to be, using our calculator, we find that tan inverse of 125 over 125 square root over 3 minus 200 is equal to 82.4776. Okay, 82.47 and 6. If we round it up to three significant figures, our alpha is going to be 82.5 degree. This is the value of the angle, okay, angle alpha. Well, then the next value is m. So any of the equation can be picked up. If we pick up this equation, let us pick up this equation. The first equation was 125 over sin alpha is equal to 125 over 10m. That means, hence 10m is equal to, here we can write here, hence 10m, or m is equal to, m is equal to, our numerator is 125, denominator is 10 into sin alpha, 10 sin alpha. How much is your alpha? Alpha is 82.477. 82.477. Hence, we get our mass of block R is 125 over 10 sine 82.4776 equal to 12.6. If we round it up to three significant figures, it is 12.6. That is what our final answer. So initially I have told that this is the most challenging question in this paper. There are many different views may arise, or different concepts may arise in your mind, but remember, simply I have thought that q is lying in the middle. So the for horizontal forces, that is, right side of q is driving force and left side of q is frictional force, I mean resistance to motion, resistance force. And while we resolve the forces vertically, then upward is the left triangle is lying upward, that's why that is a driving force. And the rest two blocks, they are lying below the x-axis, that's why they are resistance force or negative force. Then resolving in this way, it can be, I think this is the simplified form of this complicated question. Let's see the next question of this paper. The next question has also been selected from the same paper. I mean 9709 slash 42 for the session, 43 for the session May June 25, and it is question number 6. It says the diagram shows the vertical cross section ABC of a rough water slide. This is a rough surface. The section AB is a straight line of length 5 meter inclined to an angle of theta to the horizontal where sin theta is 0.8. The point B is 2.5 meter above the level of sea. A man of mass 80 kg modeled as a particle slides down the water slide. Starting from rest at A, the coefficient of friction between the man and the straight section of the water slide is zero point 0.1. Find the speed of the man at B. So directly we cannot find the speed here. There will be two steps. First we will find acceleration, okay, and for acceleration we always apply the concept of the motion law of Newton. Before that we will have to find out the components of this law, as the plane is rough. Okay, so first of all we'll have to find our normal reaction force. Before that, one more thing is given here about the angle is not given. They have written sin theta is equal to 0.8. So if it is, this is theta, 0.8 means sin theta is 0.8. That means this is perpendicular line is 8, hypotenuse will be 10. So surely our horizontal or adjacent line is going to be 6, because 6 square plus 8 square means 10 square. Well, then we will have to complete the diagram. Suppose here, okay. So this is the system. So let's find our normal reaction force. If sin theta, before that let us write normal reaction force is R plus there is no upward force, so it is 0, and downward force is mg, I mean mass, I mean weight, mg cos theta. Okay, now hence our R is going to be, mass of the particle is 80 kg, that means mass of the person is 80 kg, acceleration due to gravity is 10, and cos theta. Okay, cos theta is 6 over 10, that means 0.6. So we have got our normal reaction force is 80 into 0.6, that is 480. That is 800 into, so 480 Newton is our normal reaction force. And we are going to apply the concept of motion law of Newton, which is driving force minus, as the first direction is this, he is sliding down, so driving force minus resistance to motion is mass into acceleration. We should not forget that we require acceleration to know the velocity. So driving force is here, only weight is causing the person sliding down, so mg sin theta. Driving force is mg sin theta, and frictional force is mu r, and mass of the person is 80, acceleration is to be obtained. After that, if we substitute the value, mass of the person is 80 into acceleration due to gravity is 10, and sin theta is equal to 0.8. Already we have used 0.8, minus mu frictional coefficient is 0.1, so 0.1, and we have just got that our normal reaction is 480 Newton. 480 Newton is our normal reaction. So let us multiply by 480. 480 equal to 80 into acceleration. Okay. Now if we isolate our a, it is going to be 80 will be denominator, and here from 808 it's 640. So from 640 if we subtract 48, it is going to be, let us write 640 minus 48. Hence our acceleration is going to be, it is an exact figure, 7.4. 7.4 meter per second square is our acceleration. So applying the concept of kinematics, we can find that hence v square is equal to u square plus 2as, okay, or v is equal to square root over u square. The person started sliding from rest, so it is going to be 0 plus 2, and acceleration has been 7.4, and s is the displacement is 2.5. The displacement is 5 meters, sorry. Look at this, let me show you. The distance from a to b is actually 5 meters, okay. So the value of s is 5. It is right here 5. Hence our velocity is going to be square root over, that is 2 into 0.74 into 5, that is 8.60 meter per second. So our velocity at point B is 8.60 meter per second. That's all about this question. Then let's move on to question number 40 from paper 45. Let us solve the final question of this session. The next question has been selected from paper 9709/45 for the session May June 25, and we are going to solve question number 4 under this concept. Coplanar forces of magnitude 17 Newton, 51 Newton and 34 Newton act at a point O in the directions shown in the diagram, where tan alpha is 15 over 8. Find the magnitude and direction of the resultant of the three forces. So we'll have to find the resultant force. And before we start our solution, let us complete the diagram. Yes, this is the diagram of the system, and they have given tan alpha is 15 over 8. So tan alpha is 15 over 8 means this is the triangle where alpha, so tan alpha is 15 over 8. That means the vertical line is 15 and horizontal line is of 8 units. So what will be our hypotenuse is going to be square root over 15 square minus 8 square, that is 17 square. So it is 17. 15 square plus 8 square equal to 17 square. So our sine theta is going to be, one more triangle is required to be done. Okay, sine alpha. Sine alpha is going to be perpendicular line over hypotenuse, that is 15 over 17, and cos alpha is going to be adjacent line over 8 over 17 hypotenuse. Then one more triangle is left to be drawn. This is the final triangle which I didn't draw first. Yes, this is the final triangle. So there are three triangles. Now we are going to resolve the forces horizontally. Let us write, if we resolve the forces horizontally, so resultant force in x direction, okay, equal is not equal to. So now look at this, the positive side of x direction is the first triangle. Upper triangle is 51 cos alpha, 51 cos alpha, one of the triangles. Then the just below that, the second triangle is also in the positive direction of x from O. So that is also positive, which is 34 cos alpha. 34 cos alpha. Then in the negative direction there is another triangle, which is the third one, negative 17 cos 90 degree minus alpha, because look at this, total is 180. Okay, if the center, if this is 90, so the remaining angle will be 90 minus alpha. 90 minus alpha. 90 minus alpha. Well, then if we simplify more, it will be, let us simplify, or 51 cos alpha. 51 plus 34, it is actually 85. So let us write 85 cos alpha. Cos alpha, the 85 cos alpha minus 17 cos 90 minus alpha is actually sine alpha. 17 sine alpha. Sine alpha. Then let us substitute the values. Already we have obtained the value of cos alpha. Value of cos alpha is 8 over 17. 8 over 17. And sine alpha, value of sine alpha is 15 over 17. 15 over 17. So if we finally simplify this, this is 5 at 40. 40 minus 15, that is 25 Newton. So horizontal resultant force is 25 Newton. Now we are going to resolve the forces vertically. So let me write resolving forces vertically. Resultant force in vertical direction. So look at this, only one triangle is lying above x-axis, so that is positive, which is 51 sine alpha. Only the upper triangle, 51 sine alpha. And the remaining triangle lying below x-axis, they are negative. So minus 34 sine alpha, minus the other one is 17 sine 90 minus alpha. 90 minus alpha. Okay, then 51 sine alpha minus 34 sine alpha, if we subtract, this is going to be 17 sine alpha. 17 sine alpha. 17 sine alpha minus 17 sine 90 minus alpha is actually cos alpha. 17 cos alpha. So it is going to be finally equal to 17 sine alpha stands for how much? Sine alpha is 15 over 17. 15 over 17. I think I should write just below that. So sine alpha is equal to 17. We have already obtained sine alpha is 15 over 17. 15 over 17 minus cos alpha 17 into cos alpha, which is cos alpha is 8 over 17. 8 over 17. So finally our resultant force in y direction is going to be what? 15 minus 8, that is 7 Newton. 7 Newton. 7 Newton is our vertical resultant force. So horizontally we have got for 25 Newton and vertically we have got 7 Newton. Then they have told us to find actually the magnitude and direction. So magnitude, for magnitude, look at this. If it is our, let me show you through this. X and Y, X direction and Y direction, both of them are positive. Look at this. For X direction it is positive 25 Newton and for Y direction that is 7 Newton. So both of them are positive. That means our magnitude of force is over here. The point will be over here. Okay. So horizontal magnitude is 25. Okay, horizontal resultant force is 25 and vertical is 7. So this is actually our magnitude. Okay, let us find the magnitude of this hypotenuse. So magnitude is equal to magnitude is equal to, we know, to find the hypotenuse we just sum up the squares. So 25 square plus 7 squared, 7 squared. So it is going to be 25 square plus 7 square, that is, if we round it up to three significant figures, it is going to be 26 newton. 26 newton. So our resultant force is 26 newton. Now direction has already been, we have already decided that that is on the first quadrant above positive x-axis. But how much is the measure, how much is the quantity? So for that, let me take another ink. Okay, so direction is equal to, for a direction there is no necessity of writing in words, as I do have less space to write. So simply we look at this, vertical side and horizontal side are given, so we can use tan theta. Tan theta is equal to, vertical distance is 7 and horizontal distance is 25 units. So our theta is going to be, hence our theta is going to be tan inverse of 7 over 25. 7 over 25. Hence our angle is going to be tan inverse of, equal to, using our calculator we will find tan inverse of 7 over 25 means 15.6 degree. It is 15.6 degree. And the direction is, so how will we write direction? Then if we sum up, it can be written that 26 Newton force is acting at 15.6 degree above positive x-axis. So let me write this. So if we sum up the answer, we will write 26 Newton force acts at 15.6 degree above positive x-axis. X-axis. So our magnitude is, individual magnitude is 26 Newton, and our angle, I mean direction, is 15.6 degree above positive x-axis. So that's all about this topic. Let's move on to the next topic. Well, now our topic is work energy equation. And for solving a question under this topic, I have chosen the paper 9709/41 for the session May June 25. And we are going to solve question number 6. Let's read what question number 6 says. Two particles P and Q of masses zero point 0.3 kg and zero point 0.6 kg respectively are attached to the ends of a light inextensible string. The string passes over a smooth pulley fixed at a point B, where the inclined planes AB and BC meet. P lies the smooth plane AB, so plane AB is smooth, which is inclined at an angle theta degree to the horizontal, where sin theta is zero point 0.4. Q lies on the plane BC, which is inclined at 30 degree to the horizontal. The string is taut and the particles can move on line of greatest slope of the two planes. The particles are released from rest. And actually we are not going to solve question number A. Question number A is about tension and acceleration, which has already been solved. So let's move on to question number B. Question number B says, It is given instead that the plane BC is rough. The work done against the frictional force when Q moves 2 meter down the plane is 1.8 joule. You should assume that P doesn't reach the pulley and Q doesn't reach C. Use an energy method. They prescribed us to apply the concept of energy equation and to find the speed of Q when it has moved 2 meter down the plane. So what is the scenario? Let us see. When Q moves down, if Q slides down the slope or plane, then P will move up. So the components of work energy equation, we know the components of work energy equation are height as well as velocity. So velocity is to be obtained. So let us find the height. We can assume that these two are the systems for P and Q. So when Q was moving down, Q was moving down, P moved up. Okay, and what was the distance of their movement? It was 2 meters. So this is 2 meters, and this is also 2 meters. Then if we find the height of P traveled by P is height of P is going to be 2 sine theta. Okay, so sine theta is already given in the question. Sine theta is zero point 0.4. Okay, so it is going to be 0.8 meter for P, and for Q height of Q is 2 sine 30 degrees. Sine 30 degree. 30 degree. That means it is sine 30 means half. So if we divide, if we multiply 2 by half, it is 1. 2 into zero point 0.5 meter, that means 1 meter. So the height, the final height of particle P was 0.8 meter upward, and for Q height was 1 meter down, less than the initial height. So we are going to apply the concept of work energy equation as we have been suggested. Well, so let us write the work energy equation. Work energy equation is work done by driving force minus work done by resistance force is equal to change in GPE, gravitational potential energy, plus change in kinetic energy. Now, as the particle has been released, so there is no driving force at all acting on that. There is no external driving force. Now, work done by resistance to motion is given. It is 1.8 joule. So let us write 1.8. Now, change in GP, as there are two particles connected, so we will have to write them individually. And the formula for change in GPE is mgh. Mgh of P plus mgh of Q. Then change in kinetic energy is equal to half m v square. Half m v square. So let me write just below this, plus half m v square of which particle? Particle P. At the same time, half m v square, half m v square of particle q. So there will be two components for both GPE and kinetic energy. As there are two particles, so we will have to write the change in GPE of each of the particles, at the same time change in kinetic energy of each of the particles, because there are two particles. Please don't get confused with this. Then minus 1.8 is equal to mass of particle P is, if we go back to this page, it is zero point 0.3, and mass of particle Q is zero point 0.6. So let us write zero point 0.3 into acceleration due to gravity is 10, and height, we have already written the height of particle P, and we have learned the direction. Actually, height means the difference between the final and initial height. Look at this, P was moving up, so the height of final height of particle P is going to be positive, and it was zero point 0.8 meters. So let us write 0.8 plus mass of particle Q, which is, it should not be plus in between them, it will be minus. Let me explain why it should be minus. So mass of particle Q is 0.6. 0.6, acceleration due to gravity is 10, and height, that means difference between the initial and final height. If you look at this figure, initial height was more and final height was less, so surely it is negative. That means q was moving downward. Whenever a particle moves downward, then height gets decreased. That's why this is negative, and we always write the difference between the height. So difference between the height of q was 1 meter. Okay, that means initial height was 1 meter taller and final height is 1 meter less. That's why this is negative. Remember, if particle moves down, then the direction will be negative. It is 1 plus half of m of mass of particle P is zero point 0.3, and final velocity is to be obtained. Initial velocity was 0 because the particle was released from rest, plus, so is the second one, half mass of particle Q is zero point 0.6 kg, and final velocity of each of the particle is same, so it is simply v square. After that, if we keep on simplifying, it is going to be negative 1.8 is equal to, here if we do multiplication, it is going to be 2.4. 3 8s are 24, so it is 2.4. 2.4 minus, if we calculate this, it is going to be 6, plus, that is 1.5 v square plus zero point 0.3 v square. So total it is 0.45, 0.15 and zero point 0.3, that is 0.45 v square. Then if we isolate our v square, it is going to be 0.45 v square is equal to 0.45 v square is equal to 3.6 minus 1.8, so it is 1.8, or v is equal to, we are supposed to find velocity, v is equal to 1.8 over 0.45. Hence our velocity is going to be, 2 meter per second, and that is our final answer to this part of the question. Let it be the last of all steps. So here hence symbol. So this is one of the simplest solutions to such concept. That means work energy equation. Let's see the next question. So remember, work energy equation works on difference between the initial and final heights, as well as difference between the final and initial velocities. These are the two components. That's why always we will have to get these two components prepared before we start our solution. And here velocity has been obtained, so there is no necessity of provision of velocity, but height must be obtained. Height is one of the components, and if we find that any particular object moves down, then height will be negative because final height gets decreased. Let's see the next question. The next question has been extracted from paper 9709/42 for the session May June 25, and we are solving question number 7. Let's read question number 7. It says a particle of P. A particle P of mass 3 kg is projected with a speed of 8 meter per second up a line of greatest slope of a rough plane inclined at 30 degree to the horizontal. P is projected from a point A on the plane and comes to instantaneous rest at a point B on the plane. P then slides back down the plane. The coefficient of friction between P and the plane is square root over 3 over 12. Using an energy method throughout, find the speed of P at the instant. At the instant it returns to A. That means, look, here they have prescribed us to follow work energy equation for whole of the solution. That means it is not a one step solution. There will be at least two steps. So in every step we will have to follow work energy equation. So this is the diagram we can sketch. As the first of all, we know the components of work energy equation is components of work energy equations are difference between the final and initial heights, as well as difference between the final and initial velocities. Before that, we will have to find something else, which is, look at this, the plane is rough. Here it is given the frictional coefficient is square root over 3 over 12. That means the plane is rough. Whenever the plane is rough, we will have to find the normal reaction force. So let us see normal reaction force. R is equal to, as there is no upward force, it was projected just on the plane, R plus 0, and downward force is actually weight. Okay, so weight is mg cos angle is 30 degree, mg cos 30 degree, and equal to, it is going to be 3, that means point 0.3. The mass of the particle is 3, so 3 into 10 is 30, and cos 30 is actually square root over 3 over 2, square root over 3 over 2. So finally our normal reaction is what? 15 square root over 3, 15 square root over 3. Then we should know the final and initial height of the particle. So as it is moving up, so from this diagram we can see that the particle was projected from A and it reached B. Okay, so our height is going to be h is equal to AB sine 30 degrees, sine 30 degree. That means our height is going to be, since that is half, that means AB over 2 is the height. That means final height of the particle P. Now we can start our solution. The concept is work done by driving force minus work done by resistance to motion is equal to change in GPE plus change in KE. Since The particle was projected, that means there is no external force acting on this, so driving force was zero, work was also zero. Then work done by resistance to motion. First of all, we'll have to find the frictional force. So frictional force is actually mu r, and for work is actually AB. Okay, that means it is force into displacement. Displacement is AB. We have already found that if the particle starting from this point, particle reached until B. So the displacement traveled by the particle was AB, and work done by resistance force is equal to force into displacement. Force is frictional force, which is mu r, and displacement is AB. Then change in GPE is mgh plus change in kinetic energy is half mv squared. Then if we keep on solving more, we will get r minus mu. The value of mu is already, it is written over here. Mu is square root over 3 over 12. This one is mu is the frictional coefficient. Okay, so if we substitute the values, mu is square root over 3 over 12, and r, we have just found r was normal reaction was 15 square root over 3. 15 square root over 3 into AB equal to mass of the particle. Mass of the particle is 3 kg. Acceleration due to gravity is 10, and particle was moving up, so it must be positive. And difference between the initial and final height we have already obtained, which is AB over 2. AB over 2. Then plus half means zero point 0.5. 0.5. Mass of particle is 3 kg, and then V square is to be obtained. V square. Okay. On the left side, if we simplify, it is going to be negative 15 3 45. 45 AB over 12 over 12. On the right side, it is going to be 30 minutes. That means 30 AB over 2. Initial velocity of the particle was given. Look at this. It was projected at the speed of 8 meter per second, and finally when the particle reached at B, it came to rest surely, then it came back again. So at B, the velocity was 0, initial velocity was 8. So we can substitute that. Remember, it is V square means the difference between the initial and final velocity. So final velocity is 0 and initial velocity was 8 squared. Then if we simplify, it is going to be plus 0.5 into 3, that is 64. Okay, so 64, it must be negative, it is no more positive. So 64 half is 32. 32 3s are 96. It is 96. Actually we are trying to find the displacement of AB. Okay, then if we find AB, then we will come to know exact height. So if we write both the ABs on the left side, it is negative 45 AB minus 30 AB over 2. 30 AB over 2 is equal to negative 96. Dissolving the negative symbol from every side, we can write here, this is 12. So 45 plus, there is 63, 180. So it is 45 plus 180, it is going to be negative 225 AB over 12 over 12 equal to negative 96. Hence our AB is going to be, if we simplify more, our AB is going to be 12 into 96 over 225, which is 5.12. 5.12 meters. Well, whenever we get the distance of AB, now easily we can find our final height. So final height is going to be AB over 2, 5.12 divided by 2. That means 2.56. Hence our height is 2.56. That means final height. Initial height was 0. Well, then easily we can find the velocity. They have told us to find the velocity. Let's have a look at the question. Use an energy method. Throughout, find the speed of P at the instant it returns to A. That means after reaching B, then it came back to A. So we will have to find the displacement, I mean velocity at A when it reaches A. And whenever it starts coming downward, then initial velocity was 0, surely 0, because it was projected. There is no external force acting on this. So after projection, it reached to its highest culmination and it came to instantaneous rest. So at B, it is first we have applied the concept of energy equation when the particle was moving up to B. Then we will find the particle when the particle reaches A, what was the velocity? And initial velocity was 0 because it started from rest. So let's apply the concept once again, and for that I will have to find, and look at this. Don't forget that our final velocity, I mean height, initial height was 2.56. As it is moving downward, so now height is going to be negative. Let me find some space. So the second part is when P slides down from B. The concept is same. Work done by driving force minus work done by resistance to motion is equal to change in GPE plus change in kinetic energy. So there is no, again there is no driving force because the particle was sliding down itself. So drive work done by driving force is 0, minus work done by resistance to motion is simply it was frictional force into displacement. Displacement was AB, and we have already found the value of AB is 5.12. We have already seen that the value of AB, that means displacement was 5.AB. So we can substitute this value 5.12. 5.12 5.12 is equal to, change in GP is mgh plus half mv squared. That means final velocity minus initial velocity, or minus mu r is, mu was zero point 0.4, we have applied already over here. We can directly write this, it was 45. Look, negative 45 over 12, then AB. So simply we can substitute this, negative 45 into AB was 5.2 over 12 equal to, mass of particle P was 3 kg. So 3 into G is H. But as I have told, at this time particle is moving downward. If particle moves down, final height is getting decreased. So it will be negative. Negative 30 into 30, and we have already decided our height was 2.56 meter. This is the height we have found. AB over 2, it is 2.56. So we will have to just multiply by 2.56, 2.56 plus half mv square. So half mass of particle p was 3 and v square is to be obtained because initial velocity was 0. Final velocity is to be obtained because it was started moving down from rest. So it is simply v square minus 0. That means v square. Or if we simplify more, it is going to be, so if we simplify the digital values, it is going to be negative 96. Negative 96 is equal to, it is 1.5 v square, 1.5 v squared. Okay. Hence our v is going to be sorry, I made a mistake. It should be actually 57.6 and positive. Then on the right side, it is zero point 0.5 v square. So finally, our v is going to be square root over 57.6 over zero point 0.5. So if we divide 57.6 by 1.5, square root of that is going to be, if we round it up to three significant figures, it is going to be 6 point, let me write just beside below this, equal to 6.20 meter per second is the velocity of particle a p when it comes back to a again. So that's all about the solution to this question. Let's see the next question. The next question has been selected from paper 9709/43 for the session May June 25, and we are going to solve question number 6, which says the diagram shows the vertical cross section ABC of a rough water slide. The section AB is a straight line of length 5 meter inclined at an angle of theta to the horizontal, where sin theta is 0.8. The point B is 2.5 meter above the level of C. A man of mass 80 kg, modeled as a particle, slides down the water slide starting from rest at A. The coefficient of friction between the man and the straight section of the water slide is zero point 0.1. Find the speed of the man at B. Actually, question number A doesn't belong to our today's topic. So we are going to solve question number B. Let's see what B says. B says it is given that there is no change in the speed of the man when passing through B and that his speed at C is 11 meter per second. That means when he reached the ground, the velocity was 11 meter per second. Find the work done against the resistance force as the man moves from B to C. So before we start the main solution, we should know some of the values, because as we are skipping A has been done in another topic. As we are skipping A, so we should extract some information from solution A. So let us write from A. From A, what did we get? Initial velocity of the person, because the components of work and energy equation, we know that the components are initial and final, difference between initial and final velocity, as well as difference between final and initial heights. So initial velocity is required to be known. Let us write initial velocity. Initial velocity, initial velocity, initial velocity was square root over 74, and height, the final or initial height, look at this, the height, we are talking about the lower part of the slide, this portion. Okay, for this portion the initial height is 2.5 meter, final height is 0. So our height is, these are the information we can extract from solution number A. When the person started from B, his velocity was square root over 74 meter per second, and initially he was 2 meter 2.5 meter high. So let us start writing our solution. The work done by driving force minus work done by resistance to motion is equal to change in GPE as well as change in kinetic energy, gravitational potential energy as well as kinetic energy. And driving force, actually the person was sliding, as there is no other external pulling or pushing force. That's why driving force is zero, and work done for driving force is also zero, and work done by resistance to motion is to be obtained. So let it remain unchanged. Work done by resistance force is equal to, now change in GPE, you know, that is mgh plus half of mv square, or work done against resistance to motion is equal to mass of particle. I mean, the person was 80 and his acceleration due to gravity was 10, and height is negative. As we have learned, he was actually sliding downward. So height is negative, that is here there will be negative symbol, and height was 2.5 meter initial height. Remember, height means the difference between final and initial height. In final height is zero, that's why it is negative, and plus half of point 0.5. A mass of particle is mass of the person is 80, and v final velocity was 0, initial velocity was 11. So sorry, initial velocity was square root over 74, final velocity was 11. So that is 11 square minus 11 squared minus square root over 74 squared. Okay, remember, velocity v square means final velocity square minus initial velocity square. So v square doesn't mean that any of the v square as well as height, these are actually a difference between the final and initial height. Well, then work done by resistance to motion is, if we multiply, it is going to be negative 80 800, that is negative 2000, negative 2000, and plus it is going to be final velocity 121 minus 74. So 121 minus 74, it is 1880 joule. Hence our work done by resistance to motion is going to be, if we subtract 1880 from 2000, it is 120 joule. 120 joule is the work done against the resistance to motion. So that's all about the solution to this part. And if you get confused with negative symbol, look at this here. Height, the person was higher, at higher place initially, he was moving downward, so height will be negative, final height is 0 over here. And velocity, initial velocity at this point, this is initial velocity was square root over 74. That's why we have utilized those information. The next question has been chosen from paper 9709/45 for the session May June 25, and we are going to solve question number 1. It says a box of mass 25 kg is pulled 12 meter up a rough plane inclined at an angle of 8 degree to the horizontal. The box moves up a line of greatest slope against a frictional force of 50 Newton. The force pulling the box is parallel to the line of greatest slope. The box starts from rest and has speed 2.4 meter per second at the end of 12 meter. Find the work done by the pulling force. So the we know the components of work energy equation is difference between the final and initial heights as well as the difference between the velocities. Velocities are available, but height is to be obtained. So let us find the height. So the plane is inclined at an angle of 8 degree and the box made a displacement of 12 meter. So our height is final height is going to be 12 sine 8 degree. Okay, so this is our height. Now let's start writing our solution. Work done by driving force minus work done by resistance to motion is equal to change in GPE as well as change in KE. So work done in favor of driving force is to be obtained. So let it remain unchanged. Work done by driving force minus work done by resistance to motion. That means frictional force is already given. We know the work done by force is force into displacement. Force into displacement. And change in GPE is mgh and change in kinetic energy is half m v squared, or work done by driving force is equal to frictional force is 50 newton, 50 newton, and displacement is 12 meter. It traveled a distance of 12 meters. Mass of particle is 25 kg. The box is 25 kg and acceleration due to gravity is 10. And then height. Height is already we have found 12 sine 8 degree. 12 sine. Then plus half. Half means zero point 0.5. Mass of the particle is 25. 25. Then v square. Now look at this. The particle started at the speed, initial speed was 0 and the final speed was 2.4. So it is 2.4 square. V square means we know the difference between the initial and final velocity. So it was started from rest. Okay, it was started from rest and final velocity was 2.4. So we will write 2.4 square minus 0 square, which is unnecessary to be written. Then if we simplify, it is work done by driving force is equal to 600 is on the left side, so it is going to be positive, plus 250, that means 3000 sine 8. 3000 sine 8 is equal to, let it remain unchanged, 3000 sine 8 degree. Then if we calculate this, it is going to 12.5 into 2.4 square, that is 72. It is 72. Hence our work done by driving force is going to be, if we calculate all of this, then it is going to be, after rounding up to three significant figures, it is going to be 1090 joule. That is what the answer to this question. The next question has been chosen from the same paper 9709/45 for the session May June 25, and we are solving question number 7. It says two particles A and B of masses 6.5 kg and mkg respectively are connected by a light inextensible string that passes over a smooth pulley. The pulley is fixed at the top of a rough slope which is at an angle of alpha to the horizontal ground, where tan alpha is 5 over 12. A is on the rough slope and B hangs below the pulley. The coefficient of friction between the slope and A is zero point 0.4. Given that the system is in equilibrium, find the set of possible values of M. Actually, this belongs to different question. I mean different topics. So we are going to solve question number B. Question number B says it is given that M is equal to 12 and the particles are released from rest with the string taut. Use an energy method to find the speed of the particle when each particle has moved zero point 0.6 meter. You may assume that this occurs before A reaches the pulley or B reaches the ground. So that is what our question. We will have to, as both the questions are interconnected with the same diagram, so we will have to extract some information from the previous one. So let us write from A. From A, first of all, we should know sine alpha. Sine alpha is equal to 5 over 13. 5 over 13. Then normal reaction force was 60 Newton. 60 Newton, and mu is given zero point 0.4. Mu is the frictional coefficient between the rough surface and the object is mu is equal to 0.4. So these are the information we can extract from the previous solution. How is it sin alpha is equal to 5 over 13? Let me show you. Suppose this is a triangle, okay, and here it is written that tan alpha is equal to 12 over 13. That means 12 over adjacent is 13. If vertical line or perpendicular line is 12, so surely it is going to be, sorry, it was tan alpha was actually 5 over 12. So 5 over 12. So definitely hypotenuse is 13. So it is going to be 5 square plus 13 square, must be, Pythagoras theorem. Hence our sin alpha is, that means adjacent over, perpendicular over hypotenuse. Okay, so sin alpha is 13. Now the other component, that is height. Let us go back to the diagram. Here it is written, they have told that A was moving downward. Sorry, B was moving downward. B is moving downward, so height of B will be negative. If B moves downward, A must move up. Okay, because the direction is opposite to each other. So B is moving downward and A is moving up. For A, velocity, height is going to be positive, final height. For B, final height will be negative. So let us find the heights. So B is just moving downward, hence HB height of B, it is moving downward, simply 0.6 meter. 0.6 meter. But what about the particle A? Height of particle A will be, it is on the sliding the inclined plane, so it is not vertical height. Remember, for B is moving downward, vertically downward, but A is not moving vertically upward, it is sliding up an inclined plane. So it is to be analyzed. HA is equal to 0.6 sine alpha, and sine alpha, we have already written that sine alpha is 5 over 13. 5 over 13. That means it is going to be 3 over 13. Height of particle A is, final height is 3 over 13. Well, now we can start our solution as we do have all of the components. So let us write work done by driving force minus work done by resistance to motion is equal to change in GPE plus change in KE, kinetic energy. Now, driving force, actually there is no driving force because the particles were released from rest. So driving force is 0. Now, work done by resistance to motion, as there is a frictional force, so we know the work done by resistance to motion is force into displacement is equal to change in GPE is mgh and change in kinetic energy is half mv squared, or frictional force is mu r. Our mu is zero point 0.4 and normal reaction is 60, so it is negative 60 into 0 0.4. Then displacement was, it traveled 0.6 meter, so 0.6 equal to mass of the particle was, since there are two particles, so we will have to find the potential energy, change in potential energy of each of the particles, as well as change in kinetic energy of each of the particles. So mass of particle P is, particle P was 6.5. 6.5. Mass of particle A was 6.5 kg. So let us write 6.5 kg into acceleration due to gravity is 10. And height for A, look at this, it is negative. Okay. For A it was positive, sorry. For A it is positive and height was 3 over 13. 3 over 13. Plus mass of particle B is given, it is 12. So 12 into acceleration due to gravity is 10 and height is negative. So it should be, because B was moving down, that's why the symbol should be, symbol in front of this is negative. Negative and height was 0.6 meters. 0.6 plus. Now change in kinetic energy. Half of mass of particle P was 6.5, I mean particle A, and final velocity was to be obtained. So v square initial velocity was 0 because the particles were released from rest, plus zero point 0.5 and mass of particle B is 12 kg, 12, and initial velocity was 0, final velocity is to be obtained, which is v squared. Then if we simplify more, it is going to be minus 14.4 is equal to, that is going to be 65.5. So 15 minus 72, 15 minus 72 plus, this is going to be zero point 0.5 into 0.65 plus 0.5 into, I mean 6 into 0.65 into this, that is 9.25. 9.25 v squared, or our 9.25 v square is equal to, or 9.25 v square, if we simplify this, it is going to be 42.6. 42.6. Hence our V is going to be square root over square root over 42.6, 42.6 over 9.25, and if we round it up to three significant figures, it is going to be 42.6 over 9.25, that is 2.15, 2.15 meter per second. So that's all about this, and that has been the final solution under the same topic. And I tried my level best to explain every tiny part. It is work energy equation. In work energy equation, the components are height as well as velocity. So height means difference between final and initial heights, and velocity is also difference between the final and initial velocities. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve some questions on loss of kinetic energy. And the first of all, we are going to solve a question from paper 9709/41 for the session May June 25. And you can see on the screen, we are going to solve question number 5 from this mentioned paper. Let's read question number 5. When a particle P of mass mkg has speed u meter per second, its momentum is 4 Newton and its kinetic energy is 16 joule. Find the value of m and the value of u. So let's start our solution. In the question, it is given that momentum is 4 Newton. So we can start with this solution, with this information that momentum is given 4 Newton, and we know that momentum is the product of mass into initial velocity. So we can write mu or mu is equal to mass into initial velocity is 4. We will have to utilize this information later on. That's why we are leaving at this stage. Okay. And they have given one more information that kinetic energy is 16 joule. So we can write kinetic energy kinetic energy is equal to 16 joule. And we know the formula of kinetic energy is half of mass into v square. There is no necessity of putting this multiplication symbol mv square, and right side is 16. Well, after that, how much is our, if we look at the question, it is mentioned that speed is u meter per second. Okay, so initial velocity and final velocity is in this case actually same. That's why instead of a v square, we can write m mass into initial velocity into another initial velocity, because as speed has been mentioned, that means final and initial velocities are same. This is 16. Okay. Now, if we want to use this same information, let me write just beside this. Or if we utilize the information from the previous one, let it be left as equation number 1. Okay, so half of mu is equal to 4 from equation 1. So let us write 4, then u, again another u, and our right side is as usual 16. Now look at this. If this 4 is divided by 2, it is going to be 2u. So 2u is equal to 16. What does it mean? That our initial and final velocity was 8 meter per second. 8 meter per second. Well, we have got one of the values. They have told us to find the value of u as well as m. Now, substituting this value of u in equation 1, we get that mu is equal to. So, hence, we can write here, hence, mu is equal to, in the equation number 1, mu is equal to 4. Okay. Or u has already been obtained, so it's 8m. 8m is equal to 4. If 8m is equal to 4, our m must be zero point 0.5, because 4, if 4 is divided by 8, it is going to be 0 0.5. Okay, and we are not supposed to use this unit because already they have given, look at the question here, they have already given u meter per second. So these meter per second should not be shown over here. Okay, so let us erase this. So finally, what have we got? Our u is 8 meter per second and our m is zero point 0.5, which is the second part of the solution. That's all about answer to the question number A. Let's move on to question number B. Question number B says P is now projected on a smooth horizontal surface with speed v meter per second directly towards a particle Q of mass 1.25 kg, which is stationary. After P and Q collide, the velocity of P is w meter per second and the velocity of Q is 2w meter per second. The loss of kinetic energy in the collision is 25 joule. Find the value of V and the value of W. So it's all about loss of energy, and since the question number B belongs to conservation of momentum, we are not solving this right now. We are going to, our today's topic is actually loss of energy. So let's see, the immediate next question is about loss of energy, and as solution to B belongs to conservation of momentum, we will solve this solution, or we will solve this question in the topic when we discuss momentum of conservation. Let's see question number C. But I think as both the topics are related to each other in the same question, it is better we apply the concept of the conservation of momentum, and finally we will found the loss of energy. So let's start with the conservation of momentum. And you know, the concept of the conservation of momentum is ma into initial velocity, not a, it is actually first particle was p. So mp into initial velocity of p plus mq, the other particle, and initial velocity of particle q is equal to final velocity mass of particle p into final velocity of particle p, as well as initial velocity mass of particle q into final velocity of q. Now we are going to substitute the values. The mass of particle p is, let us see what is the mass of particle p. It is written mass of particle p is mkg. Okay, and we have just obtained the value of m as 8. Okay, sorry, not 8, m was zero point 0.5. Look at this, we have obtained here m is equal to 0.5. So mass of particle p is 0.5 and mass of particle q is given over here 1.25. Okay, so we have got the values of the masses of particle p and q, and initial velocity of p was, we have already obtained. Initial velocity of particle p was u meter per second. No, it is not u, because we are dealing with a different scenario. Here initial velocity of particle was v meter per second. Okay, and initial velocity of q was, it was stationary. Okay, q was stationary, means 0, and after collision final velocity of particle p was w, and the final velocity of particle q was 2w. So one after the other we are going to apply the values. The first one is mass of particle p, as we have seen it is 0.5, 0.5 into initial velocity of particle p is, it is written w, sorry, not w, it was, it is v. Okay, so v plus mass of particle q is 1.25, 1.25, and initial velocity of particle q was 0 because it was stationary. Look at this, here it is written stationary. Q was at stationary level. Then mass of particle p is 0.5. Then final velocity of particle p was w, plus mass of particle q is 1.25, 1.25, 1.25 into final velocity after the collision. Final velocity of q was 2w, 2w. Now if we simplify, it is going to be 0.5 b on the left side. On the right side it is, look at this, 0.5w and 2 into 1.25, that is 2.5, so it is 3w, 3w, or v is equal to, if we transpose this 0.5 to the right side, 3 divided by 0.5 is it going to be 6w. So final velocity is 6w meter per second. Okay, v is equal to 6w meter per second. This is the information we are going to apply in the concept of the loss of kinetic energy. Now we can write loss of kinetic energy is given as loss of kinetic energy of kinetic energy kinetic energy is equal to 16 joule, sorry, 25 joule. Look at this, the loss of kinetic energy given is 25 joule, so we have formed an equation with this. Now we know the formula of loss of kinetic energy is change in kinetic energy of the first particle. Change in kinetic energy, the name of the first particle is p, and minus change in kinetic energy of the particle q. There are two particles, they have collided, that's why both of the particles should be considered. It is 25. Okay, and the formula we know about that change in kinetic energy, the formula of change in kinetic energy is actually half m v square. So negative half m, then m of which one, mass of particle p, then v square, minus change in kinetic energy is equal to the same concept, the mass of particle q, then v square, and our right side is 25. Okay, now let me see where to write the next part. On the right side we can continue writing. Let us substitute the values we do have. Or half means negative zero point 0.5, zero point 0.5, and mass of particle P is already we have used, which is also zero point 0.5. So 0 0.5 and v square. Yes, this is the crucial point. Remember, v square means it is not only one velocity. V square means the difference between the final velocity square of the final velocity as well as initial velocity. So this is not one of the velocities, this is the difference between the final and initial velocity. So let us see what was the final velocity of particle P. Final velocity of particle P is given. Look at this in the question. What is given? Final velocity of particle P was W meter per second. So we will write final is W meter per second, and initial was what? Initial has been used. It was actually V. So initial velocity was V. We are talking about P, and final velocity was W for P. So remember, v square means final velocity minus initial velocity. Final velocity was W. So let us write W square, and initial velocity was v square. We have written first quantity minus the second one also goes, so half is zero point 0.5. So 0.5 into mass of particle Q was 1.25, and final velocity of Q is, final velocity of Q was, let's see what was the final velocity of Q. The final velocity of Q was 2W. It is given as 2W. So we will write 2W square. 2W square means 4W square minus initial velocity. Initial velocity of Q was actually 0. Look at this. Initially Q was at stationary level. It is written which is stationary. It is written over here Q was in stationary mode. So there was no motion, hence we can write here 0. This is 0 for Q. So remember, for loss of kinetic energy, our concept is final velocity minus initial velocity, and our right side is 25 here. Now if we continue our solution, it is going to be, if we multiply 0.5 into 0.5, it is going to be 0.25, 0.25, 25. Then W is equal to what? Look at this. Our V has been already obtained. V is equal to, in equation number 1, or in the first part of this solution, we have found our V is equal to 6W. So it is going to be 6W square means, sorry, W square, V is equal to 6W square. So 6W square means actually 36W square. So this is the first part. Then if we multiply 0.5 by 1.25, 0.5 into 1.25, it is going to be 0.5 into 1.25, it is going to be 0.625. So 0.625 into 4W square into 4W square. 4.625 into 4W square, if we multiply by 4W square, is equal to 25. 25 is our right hand side. Well, now what is it going to be? From 36, if we subtract 1, it is going to be 35. w square. So if you multiply 35 by 0.25, it is going to be 8.75. 8.75 w square minus 4 into 0.625, it is going to be 2.5. 2.5 w square is equal to 25. 25. Now you may raise a question that whereas this minus symbol went to, if we multiply this minus symbol with this minus symbol, it is getting positive because 36 is greater, so it will be negative, negative, positive. And on the in the next quantity, actually there is nothing in front of negative symbol, so it will remain positive. Now from 875, if we subtract 250, it is going to be, it is going to from 8, so 6.25, it is going to be 6.25 w square is equal to 25. Then if we divide 25 by 6.25, it is going to be actually 4. Okay, so w square is equal to 4, hence our w is 2, because final velocity, they were in motion, it was not in negative. We are picking up the positive result since w is more than 0. Look at this, it was written that after the collision the velocity of q was 2 meter per second. Okay, so it was moving onward. Actually when they collide each other, there is no way to wait for q to go back, so definitely this is positive. Okay, so w is positive. Now w is 2. The other value we have to find is v is what, from here if we look, v is equal to 6. Here v is equal to 6 w, hence our v is going to be, let us write, hence v is equal to 6 2s are what, 12. V is equal to 12. So these two are the answers we should show. And that's all about the solution to this question of paper 41 9709 slash 41 for the session May June 25, question number 5. This is whole of the solution at a glance. Now we are going to solve another question based on loss of kinetic energy. The next question we are going to solve is from paper code 9709 slash 42 for the session May June 25. And we are solving question number 2, which belongs to the same topic we are discussing today. Let's see what the question says. It says two particles P and Q of masses 0.2 kg and 0.1 kg respectively are free to move in a straight line on a smooth horizontal plane. P is projected towards Q with speed 5 meter per second. At the same instant, Q is projected away from P with speed 2 meter per second. When P collides with Q, the particles coalesce. Find the kinetic energy lost during the collision. Well, let's start the solution. And as there is a collision, we should know the velocity before the collision and after the collision. And the components of loss of energy or loss of kinetic energy is the difference between the velocities. So we should know first of all the initial velocity as well as final velocity of the two particles. So let's start our solution with application of the conservation of momentum to know the velocities initially and finally. Conservation of momentum is mass of particle p into initial velocity of p plus mass of particle q into initial velocity of q equal to mass of particle p into final velocity of particle p plus initial mass of particle q into final velocity of particle q. So let us substitute the values. If we substitute the values, mass of particle p is 0.2 whereas q is 0.1, and initial velocity of p was projected towards q with 5 meter per second. So it is 0.2 into 5 plus mass of particle q is 0.1, and it at the same instant q is projected away from p. Away from p means actually it is to the same direction as p was moving on. So the initial velocity of q is 2 meter per second. Now mass of particle p is 0.2 and final velocity after the collision, look at this, the both the particles coalesce. Coalesce means both of them were moving together being one single particle. That's why it is neither p nor q. It is simply we are going to find the final velocity as v. And mass of particle q is 0.1, as both of the particles coalesce means got together, so their velocity is also same. Now on the left side, if we calculate 5 into zero point 0.2 is 1 plus zero point 0.2, so that is 1.2, and right side is going to be 0.2 v plus 0.3 v, so 0.3 v. If we divide 1.2, I mean 12 by 3, it is going to be 4. Hence, our V is equal to, let me write just beside this. Hence, our velocity is going to be 4 meter per second. That means after the collision, both the particles moving onward together at the speed of 4 meter per second. Now we are going to find loss of energy. So let us write loss of kinetic energy. Loss of kinetic energy, kinetic energy equal to, we already come to know the formula of kinetic energy from the previous solution. Let us write just beside this equal to negative symbol. Remember, whenever loss of energy occurs, then we will use negative symbol. Change in kinetic energy of particle, first particle P, minus change in kinetic energy of particle Q, means the second particle, equal to, if we use this equation, not equation actually, so equal to, it is going to be, let me write equal symbol over here. Okay, negative symbol. And what is the formula for change in kinetic energy? We have applied in the previous solution. It is negative 1, I mean half, mass of particle P and velocity, difference between the initial and final velocity, square of the velocities, minus again the second one, mass into mass of the second particle q and final difference between the initial and final velocity. Let us substitute the values. It is going to be negative 1, I mean half, mass of particle p was 1.2, so it is going to be 0.2, and final velocity after the collision of particle p was, we have obtained, it was 4 for each of the particles, so 4 squared, final was 4. Initial velocity of particle p was, this was the initial velocity, minus 5 squared. So is the next part, minus half, and mass of particle q is zero point 0.1, so let us write 0.1. Final velocity of particle q was 4. It was applicable for each of them because after the collision, each of the particles, both of the particles form a new particle whose velocity was 4. So 4 squared minus initial velocity of particle q was 2 meter per second. So 2 squared. 2 squared. Well, then let us calculate this. Look at this. 5 square means 25. From 25, if we subtract 16, it is going to be 9. And if we divide this zero point 0.2 by 2, it is going to be zero point 0.1. Zero point 0.1 into 60 and 60, I mean 16 minus 25 means minus 9. So it will be positive because both the minus, this minus symbol will multiply this minus symbol, so it is positive now. Well, after that minus, if we divide zero point 0.1 by 2, it is going to be 0.05. 0.05 into 16 minus 4, it is 12. So if we simplify more, we will get zero point 0.9 minus, if we use our calculator directly, it will show. Let me use our calculator. If we use our calculator, it will show that zero point 0.9 minus zero point 0.6. So it is actually zero point 0.3 joule is the loss of energy we have found. They have told us to find the loss of energy, which is zero point 0.3 kilojoule. So that is all about the solution to the second question of the same topic. Let's see one more question. The next question we are going to solve is from the paper 9709/43 for the session May June 25. Let's see what the question says. It says we are solving question number 1, and it says two particles P and Q of masses 0.1 kg and 0.3 kg respectively are at rest on a smooth horizontal plane. P is projected directly towards Q with speed 4 meter per second. At the same instant, Q is projected directly towards P with speed u meter per second. After P and Q collide, P moves with speed 2 meter per second and Q moves with speed 4 meter per second. Question number A says find the two possible values of u. Solution number U belongs to conservation of momentum, as already we solved two questions applying the conservation of momentum. In this question, we are not going to apply the concept of the momentum, conservation of momentum. We will directly go to our today's topic. Our today's topic is loss of kinetic energy. So for loss of kinetic energy, initial and final velocities are the components. And from question A, we have got that we have solved it in another session actually, but the value of u is 14 meter per second. So let's start our solution with this one. U is equal to, let us write here, u is equal to, we can write here from a, from a, our u is, there are two values obtained in A. One was u is equal to 10 as well as 14 meter per second. Let us write whether we should write unit or not. It is yes. U is 10 as well as 14. 10 as well as 14. Now look at this. The question number B says find the largest possible loss of kinetic energy. For largest possibilities, we will have to know that as there are two values of initial velocities, so if the initial velocity is larger, we will choose the larger initial velocity, because we can write here for larger initial velocity, for this is not the solution to A. Remember, we are solving solution to B. So this I think I should not write over here. I should write at B. Let this comment be written for larger velocity, for larger initial velocity, larger initial velocity, for larger initial velocity, the loss of energy is also larger. The loss of energy is also greater. Okay, that means if the initial velocity is larger, then after the collision, loss of energy will also be greater. Now we are going to apply the concept. We know the loss of energy formula for loss of energy is change in kinetic energy. So let us write loss of energy is equal to loss of loss of kinetic energy. Kinetic energy is equal to negative symbol change in kinetic energy. Change in kinetic energy, as there are two particles P and Q. Change in kinetic energy in P minus change in kinetic energy of Q. Okay. Then if we apply the formula, we know what are the formula. The formulas are half m v square. Okay, so let us write equal to half negative half m mass of particle p and difference between the final and initial velocity of p minus half of, so is q mass of particle q and mass of particle q and difference between the final and initial velocity. So let us substitute the values. It is negative 0.5. Okay, 0.5, and mass of particle p is, already we have come to know, mass of particle p was what, 0.1, one was 0.1, another one was 0.3. Okay, so we are going to write 0.1 and final velocity of particle p. This is also given in the question. Final velocity of particle p was, look at this, 2 meter per second for p, and for q it is 4 meter per second. So let us substitute these values. The final velocity was 2 meter per second, so 2 square. Remember, we use v square, means final velocity, square of final velocity minus square of initial velocity, minus initial velocity. Now let's see what was the initial velocity of p. Initial velocity of p was, it is written initial velocity of p, this. Initial velocity of particle p was 4u. Okay, and initial velocity of particle q was only u. So for p it is 4u, and we know we are going to apply u is equal to 10. So 4u means 40. Sorry, we are going to apply u is equal to 14. So it is 414. 414 means 56. It is going to be 56 squared. Okay, please don't get confused that how is it 56 square, because for initial velocity of p, once again I am showing, initial velocity of p is 4u. So if u is 14, so 14 into 4 means 56. That's why for p, initial velocity was 56 meter per second. So we have written here 56 square, then minus zero point 0.5 for particle q, and mass of particle q was zero point 0.3. We have already seen it was 0.3, 0.3, and the final velocity of particle q was, it was u, means 14. 14 square, sorry, final velocity of particle q was, let us say once again, final velocity of particle q was 4 meter per second. Look at this, it was 4 meter per second. So let us write 14 square, 14 square minus initial velocity was u square for q, so it is not 14, it was actually 4. Final velocity was 4 and initial velocity was 14 for q, so let us write 14 square. Okay, now if we simplify this, we will get equal to 56 square minus 4 square. Let us multiply all of this. In the first case, look at this minus symbol this symbol and this symbol, they are getting together positive. So let us calculate using calculator. Using calculator, we got that our result is here positive 156.6, 156.6, 156.6, and here also the greatest symbol is negative, so it is going to be positive. And if we multiply 0.15 into 180, it is 27. 27 plus 27, and if we add up these two quantities, it is going to be 183.6 joule if we round it up to three significant figures. So that's all about this question, and that is the final question of today's session. And I tried my level best to explain the concept, that means loss of energy or loss of kinetic energy. It is simply that is change in kinetic energy of one particle and change in kinetic energy of the other particle. But the most important part is v square. In v square, always we will have to write the final velocity first. It is actually v square means final velocity square minus initial velocity square of each of the particles. Okay, that's all about the solution. So thank you all for being with me, and may Allah bless all of us with the beneficial knowledge. Allah Hafiz, fi amanillah. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve some questions on forces and equilibrium. And the first of all, we are going to solve a question of the same topic from question paper 9709/45 for the session May June 25, and we are going to solve question number 7. Let's see what question number 7 says. It says two particles A and B of masses 6.5 kg and m kg respectively are connected by a light inextensible string that passes over a smooth pulley. The pulley is fixed at the top of a rough slope which is at an angle of alpha to the horizontal ground, where tan alpha is 5/12. A is on the rough slope and B hangs below the pulley. The coefficient of friction between the slope and A is 0.4. Given that the system is in equilibrium, find the set of possible values of m. Well, before we start the solution, we should know the fact about a particle when it is held equilibrium on an inclined plane. Look at this. About B, the slope is rough and the particle A is held in equilibrium. So whenever a particle is held equilibrium, there are two possible cases. Okay, remember, if we don't understand the fact about a particle which is held equilibrium by another external force, actually what should be the natural scenario? Suppose here the particle is over here. So what are the possible cases? The particle was about to naturally, if it is just released, then it will slide downward, slide down the plane. So this is one of the cases. But if you apply external force, then it could move up the plane. So there are two possible cases for a particle held equilibrium on an inclined plane. So let us write this scenario. Actually, we should know the fact, and before we start the solution, we are going to write this. There are two possible cases. There are two possible cases. Two possible cases for a particle held. A particle held in equilibrium on an inclined plane. Okay, what are the cases? Let me write it once again. So whenever a system is given to us, when a particle is held in equilibrium, we should not forget these two concepts. Look at this, I have written here, so please keep this in mind before starting the solution. There are two possible cases for a particle held in equilibrium on an inclined plane. Either the particle is about to slide down, or the particle is about to slide up. So keeping these two concepts in mind, we are going to solve our question. So this is our question. Before we start solving this, let us collect all the supporting information. Okay, first of all, we will complete the diagram for A, because B is not to be considered here. First case, we will have to solve A. Okay, so for A, let me complete the diagram. This is normal reaction, and it is weight, and our angle is alpha. Well, and then there is another information given, that tan alpha is 5 over 12. Okay, so for tan alpha, we should know that this is the diagram. Okay, and we know that tan alpha is equal to what? Sine over, opposite over adjacent. So opposite is 5 and adjacent is 12. So what will be our hypotenuse? If it is so, hypotenuse is going to be 13. How is it possible? Let me show you. Look, 5 square plus 12 square is equal to 13 square, according to the Pythagoras theorem. Okay, so our hypotenuse is going to be 13, and this is for A. We have completed the diagram. On completion of the diagram, first step of our solution will be finding the normal reaction, because the particle A is kept on a rough slope. Look at this, it is written over here, the slope is rough, so definitely there is a resistance to motion, frictional force. So let us find the frictional force, normal reaction. Normal reaction is R plus there is no upward forces acting on particle A, so upward force is 0 and downward force is mg cos alpha. Okay, or r is equal to, r is going to be mass of particle A is 6.5. So 6.5 into 10, 6.5 into 10, 6.5 into 10, and now we will find cos alpha. Okay, so sine alpha is equal to sine alpha. Let me write this above that. Sine alpha is equal, okay. Sine alpha is equal to, very sure it is 5 over 13, 5 over 13. 5 over 13 is sine alpha. That means vertical side or opposite over hypotenuse. Then cos alpha. Cos alpha is equal to, just opposite to that, cos alpha is going to be your adjacent over hypotenuse. So adjacent is 12. 12 over hypotenuse is 13. So our cos alpha is 12 over 13. Just here we will write 12 over 13. 12 over 13. Hence our normal reaction is what? R is equal to 6.5 into 10, 6.5 times 10 is 65, and if 13 divides 65, it is 5. 5 12 plus 60. So our normal reaction is 60 Newton. 60 Newton is our normal reaction. Well, we have got all of the supporting information. Now it's time to start writing our solution. We have not forgotten that there are two possible cases. One after the other we will solve the question. So between the two cases, first of all, let's assume the particle is about to slide down, that is supposed to slide down. So let's start writing for A. Look, we have not yet discussed anything about B. All of the discussion is centered to A. For particle A, if it is supposed to move downward, then what are the forces? We will have to resolve the forces, and our topic is forces and equilibrium. Well, let's see the concept. Whenever we find the resultant force, always apply the concept of the motion law of Newton. And what is the motion law of Newton? Driving force minus resistance to motion is equal to mass into acceleration. Okay, so if it is supposed to slide down, what is the driving force? Actually, there is nothing which is causing it move downward except weight. So weight is mg sine alpha, mg sine alpha. And what is the tension, what is the resistance to motion? Number one resistance to motion is tension, because there is another particle hold, which has been held tight between this with an inextensible string. That's why the tension is the major resistance to motion, and another resistance to motion is actually frictional force. And we know that the frictional force means mu into r, frictional coefficient into normal reaction, equal to mass into acceleration. Look at this, as the system is in equilibrium, so there should be no movement or acceleration at all. That's why right side is 0. Let us substitute the values of m and g. M stands for 6.5. The mass of the particle is 6.5. So let us write 6.5. 6.5 into acceleration due to gravity is 10, and sine alpha, we have already obtained the value of sine alpha is 5 over 13. So 5 over 13 minus mu. Mu is the frictional coefficient, which is frictional coefficient is given as zero point 0.4, so it is 0.4, and normal reaction has been obtained as 60. We have already obtained. Before starting the solution, always we will find the normal reaction first of all, before, because in case of a rough slope equal to t, okay, hence our t is going to be, let us write t. If we make t as subject, t is going to be, look at this, 6.5 times 1065. If we divide by 13, it is 5. 5 fives are 24. So this is 5 fives are 25. So let us write 25 minus 4 sixes are 24. It is going to be 24. Hence our tension is going to be 1 Newton. 1 Newton for one of the cases. We should not forget that there are two possible cases. Tension is 1 Newton when the particle was supposed to move down. So the other possibility is when the particle moves up. So for moving up, the direction is, it is moving like this, okay, and the concept we are going to apply is exactly same. Driving force minus resistance to motion is equal to mass into acceleration, okay. If the particle is moved up, then what is the force actually here? Look at this. If the particle tries to move up, what is the force? Nothing but the tension. Only tension is trying to move the particle upward. So we will write tension as driving force. Tension. And what are the resistance to motion? What are the resistance motion or resistance forces are? Number one is our weight is trying to move it downward, so that is mg sine alpha, and the other forces, as the plane is rough, so frictional forces also causing resistance, which is mu r equal to, right side must be 0 because the system is in equilibrium. Now if we simplify these, if we substitute the values, our t may be on the left side, okay. Mg sine alpha, look at this, already we have found mg sine alpha is this. Mg sine alpha is going to be 25, okay. And mu r, already we have found our mu r is also 24. It is 24, so plus 24. Just the direction has been changed, but quantity magnitude is same. So our tension is, for the second possibility, our tension is going to be how much? 25 plus 24, so 49. Hence our tension is going to be, for the second possibility is 49 Newton. So long we were analyzing the forces acting on particle A. Now this is the turn of particle B. There are two possible cases for B as well. So we will write for B also. So one of the cases is either it will slide down, I mean move down, or move up. So if the particle B move up, then what is the driving force for B? This, let us write the concept. Concept is driving force minus resistance to motion. Driving force minus resistance to motion is equal to mass into acceleration, okay. So it is going to be, driving force is nothing but the tension is trying to move it up, and the resistance to motion, look at this, this is hanging, so the particle B is hanging, so there is no question of normal reaction or frictional force, anything else. Just weight is trying to move it downward, so weight is the negative force here, or resistance to motion. So weight is mg. If you calculate, it is cos 0 degree, because angle is 0 in terms of this. Or if you use sine, let me write sine angle, it's all the same, sine 90 degrees, sine 90 degree. Let us write sine 90 degree equal to, right side must be 0, because the system is in equilibrium. So let us see our tension. Already we have obtained our tension. For the first case, our tension was, let us see, first case tension was 1 when the particle was sliding, A was sliding down, B was moving up. In that case, our tension was 1 Newton. So we are going to substitute 1 is equal to mass of particle B is m. So acceleration due to gravity is 10. So this is 10 m. Okay. Now if we simplify m, then m is going to be, hence m is going to be, if we divide 1 by 10, it is 0.1. So this is one of the masses of particle, one of the possible masses of particle B. Then for another possibility, when the particle was sliding down, I mean, if particle A moves up, then B will moves down. So for B, same concept, that is driving force minus resistance to motion is equal to mass into acceleration. Well, so driving force, when the particle B moves down, driving force is nothing but weight. So weight is mg sine 90 degree. And what is the resistance to motion when the particle B was trying to move down? The tension is causing the resistance, and acceleration is 0, so right side is 0. Hence our T is going to be, T is equal to, mass of the particle was m and acceleration due to gravity is 10, so this is 10 m. Well, now if our tension, if we substitute the second value of tension, because this time particle A was moving up whereas B was moving down. Okay, so when particle A was moving up, the tension was what? We have already found that the tension was 49 Newton. It was 49. So let us substitute this. 10 m is equal to 10 m is equal to 49 Newton. Okay, hence our m is going to be 4.9. Now if we look at the question has told find the system, given that the system is in equilibrium, find the possible values of m. That means m will have a range of values. What is the range of values? We can write, finally, if we want to write the answer will be this. Look, the minimum value was what? 0.1. So it is zero point 0.1 until point 4 point, I mean 4.9. This is our final answer. This is our final answer. That means when the mass of particle B is from ranging from zero point 0.1 kg to 4.9 kg, then the particle, both the particles will be in equilibrium state. So what does this, the answer solution has been completed, but for your better understanding, I would like to explain. Look at this. When m is less than zero point 0.1 kg, then B will move downward. Okay, sorry, B will move up. If the weight of particle, I mean mass of particle B is more than 4.9 kg, then particle B will move down. I can include this sentence so that you can understand it well. Let me write over here. This is not the part of your solution, but for your better understanding, I am just writing. Okay, so it will be actually, if the two values will be like this, if m is less than zero point 0.1 kg, zero point 0.1 kg, then B will move up. B will move up. B will move up. First possibility, if if mass of particle B is greater than 4.9 kg, 9 kg, then particle B will move down. So this is actually the twist of the question. Actually, the answer can be written that particle, the mass of particle B is ranging from zero point 0.1 until 4.9 kg for being equilibrium. But what does it actually mean? It means if the mass of particle B is less than zero point 0.1 kg, then it will move up. If the mass of particle B is more than 4.9 kg, then B will move down. Sorry, it is down. Here I should write down, not up. It is going to be down. It will move down when the mass is more than 4.9 kg. So this is all about this solution. If you can solve it and analyze the forces individually, then I don't find that this is very complicated. But initially the question seems to be very twisted, but factually this is not at all. So what is the first, once again I am going to the first concept. Look at this, the concept we have applied at the beginning is, there are two possible cases for a particle held in equilibrium on an inclined plane. Remember, you should not forget this. Either the particle is about to slide down or the particle is about to slide up. So in both cases you will have to resolve the forces. If you can do so, I believe that it will never be a difficult task for you. Well, let's see the next question, which belongs to the same concept, forces and equilibrium. The next question has been selected from paper 9709/42 for the session May June 25, and it is question number 3. Let's see what it says. A particle of mass mkg is attached to one end of a light inextensible string of length 2.6 meter. The other end of the string is attached to a fixed point on a horizontal ceiling and the string is taut. The particle is held in equilibrium by a force of magnitude 35 Newton acting in a vertical plane which is perpendicular to the ceiling and contains the string. The force acts in a direction perpendicular to the string. The tension in the string is T Newton and the vertical distance of P from the ceiling is 2.4 meter. Find in either order the value of M and the value of T. Okay, we know whenever we resolve the forces, first of all, we complete the diagram in terms of triangle. So let us do so. If we complete the diagram, look at this. These are the directions. This is x-axis, okay, x-axis. And here, this is a triangle and another triangle is this one, okay. And which is the tension? This is actually our tension or the string. Well, now let us see what is the angle. Let it be alpha, as well as this one is beta, okay. So this is the completion of diagram, and whenever we resolve the forces, we should know the measure of the angle. So one after the other we can find the angles. Let us find the angle alpha on the left side. So for alpha, it is, look at this, hypotenuse is given 2.6 and height is given 2.4, that means opposite. And we know that T, that means hypotenuse into sine angle, sine angle of sine alpha is equal to, opponent is 2.4, 2.4. Remember, without having the measure of angle, we cannot resolve the forces. So our tension is given 2.6 meters, 2.6 sine alpha is equal to 2.4, 2.4. Or our alpha is going to be sine inverse of, sine inverse of 2.4 divided by 2.6. 2.4 divided by 2.6. Hence our alpha is going to be, if we use our calculator, using our calculator we got that our alpha is 67.38, 67.380101. I have taken some more digits after decimal, more than necessary, because actually to get the more accurate answer we can write some more digits after the decimal. Then if alpha is 67.38, so beta is going to be, look at this, total is 180. From 180 if we subtract this from 90 minus this, so from 90 if we subtract 67, look at this, the middle angle is a right angle. So from 90 if we subtract 67.3801, rest one is our beta. So 22 point, it is going to be 22.6198, 619865 degree. 65 degree is the measure of angle beta. So as we have got the measure of each of the angles, now easily we can resolve the forces, because for finding tension we always resolve the forces, and our topic is today forces and equilibrium. Well, then, first of all, we will resolve the forces horizontally, and the concept is the motion law of Newton, that is, driving force minus resistance to motion is equal to mass into acceleration. Well, so driving force for particle, this is for particle from the first triangle, not particle, first triangle, I mean left side. Okay, for, let us start with the left side. It is going to be, no, let us start with the right side, sorry, it's a mistake. Driving force will be on the right side, a positive force. So it is 35 if we choose this triangle. So 35 cos beta, 35 cos beta is the positive force, minus the negative direction of x is what? T, T cos alpha for the second, this diagram, this triangle. And as the system is in equilibrium, so there is no motion at all, right side is 0. Okay, have you forgotten that this is our topic is forces and equilibrium, so right side is 0. Now we are going to substitute the values, or 35 cos beta, we have already obtained, beta is 22.6198, 619865 equal to tension into cos alpha. Cos alpha, the measure of alpha is 67.3801. Then if we make T as subject, so T is equal to, or T is equal to 35 cos 22.619865, which should be divided by cos of 67.3801. Hence our tension in this string is going to be, using our calculator we get that tension is 83.99989. So if we round it up to three significant figures, it is going to be actually 84.00, 84.0 Newton. This is the one of the answers we should show. Okay. uh, Actually exact magnitude will be 83.99, but we will have to round it up to three significant figures, then it is going to be 84.0. So this is the value of t. Now let us find the value of m, I mean mass of particle P. Okay, so for that we have resolved the forces horizontally. Let us resolve the forces vertically. If we resolve the forces vertically, our concept is actually same. Okay, the concept is motion law of Newton. So let us write here vertically. The concept is same: driving force minus resistance to motion is equal to mass into acceleration. Now let's see what is the upward force, driving force. Upward force is for P is what? For the first, I mean right side triangle, it is 35 and angle will be sine. Sine, first of all, if we take beta, we can take the right side first. Beta plus another one is also upward force. So tension sine alpha and minus the resistance to motion. So long these were upward force, now downward force is nothing but the weight, which is mg sine 90 degree, mg sine 90 degree, mg sine 90 degrees. Sometimes you may get confused that we simply write mg, why don't we use angle? That's why to remove that confusion, I just write that sine 90 degree, because angle will be 90 degree, equal to 0, equal to 0. Then let us substitute the values. If we substitute the values, we require m. Okay, so let us write m on one side. Acceleration due to gravity is 10 and sine 90 is 1, so it is going to be 10 m. It is going to be 10 m. 10 m is equal to, if they move their places, it is going to be 35, 35 sine beta sine beta plus tension sine alpha, tension sine alpha. Or our m is the subject, so m is equal to, m is equal to, denominator is 10 and numerator 35 sine beta, 35 sine beta sine beta. Beta is equal to how much? 22.619. So 22.619. I do not have sufficient space, so I will have to zoom it out. Zooming is not necessary, just continue to write. Our tension was what? 84 Newton, or it was 83.99, 83.99. Then sine alpha, alpha is 67 point something. I require some space more. Let me continue writing again. Yes, that is the our step. So our mass of particle P is going to be, if we use our calculator, 35 sine 22.67 plus 83.99 sine 67.38 is equal to 9.099. That means if we round it up to three significant figures, it is going to be 9.0 9.1, sorry, 9.1, 9.10, up to three significant figures. So that is what the final answer to this question. And I think that this is not difficult at all for any one of you. And I tried my level best to explain every tiny part of this solution. Let's see one more solution of this session. The next question belongs to paper 9709/41 for the session May June 25, and it says three coplanar forces of magnitude P Newton, 5 Newton, and 10 Newton act at a point O as shown in the diagram. The resultant of the three forces has magnitude Q Newton and acts in a direction perpendicular to the force of magnitude P Newton. Find the value of P and the value of Q. So actually there is a twist in the question. Look at directly they didn't mention the resultant force. They have written that the resultant force of magnitude Q Newton acts in the direction perpendicular to force of Pn. So P is this one. If P is perpendicular, I mean vertical one, so Q will be actually over here. At this is, look at this. They have written perpendicular to the force of Q. If this is P, if this is P, Q should be over here. So this is the actually twist of this question, because we may get confused that where Q can lie or what is the direction of Q. So once again I am repeating that it is, as they have told, the Q will be perpendicular force to P. So this is actually our Q. Well, and we are going to solve question number 2 of this paper. First of all, we will have to complete the diagram. This angle and this angle. So let me draw the diagram. Well, before finding the final result, I have explained that Q is, direction of Q should be over here. But how can it be over here? How can we be so sure that it could have been, this is the condition is it will be perpendicular to P, so it could have been on the negative direction of X also. Let's see actually finally where Q lies. First of all, we will resolve the forces vertically. If we resolve the forces vertically, it is going to be driving force minus resistance to motion is equal to mass into acceleration. Okay, we are applying the concept of the motion law of Newton. So driving force for P, this is our vertical direction. Okay, so for vertical direction, first of all, if we take the right side triangle, it is going to be 5 sine 60, 5 sine 60 degree plus P is also acting upward. If you calculate the weight here, mg, P and sine 90 degree, P sine 90 degree, because sometimes if I simply write P, you may get confused. You may think that why are we not calculating angle in case of P. Actually angle is calculated everywhere. Here angle is 90 degree. That's why sometimes it remains invisible. So P is sine 90 degree, and the negative one is negative force is third triangle. I mean this triangle. So for this triangle, it is going to be our magnitude is 10. So 10 sine 30 degree. 10 sine 30 degree, sine 30 degree is equal to, as we have already seen that vertically, look at this, the resultant force is perpendicular to the force of magnitude. That means it is somewhat horizontal resultant force. So vertical resultant force is 0. Remember, we should understand that they told that the direction of the resultant force is perpendicular to P. That means vertically there is no resultant force which is 0 actually. Okay, so our right side is going to be 0. It is 0. Now let's see sine 60. We know that sine 60 is equal to root over 3 over 2. So 5 square root over 3 over 2 plus p minus sine 30 is half. So 10 over 2 equal to 0. If we isolate p, then it is going to be, or p is equal to this is 10 divided by 2 is 5 minus 5 2.5 square root over 3. Hence our p is going to be, p will be, if we subtract 2.5 root over 3 from 5, the answer is going to be, it is 0.6698. So if we round it up to three significant figures, it is going to be 0.670. So this is the magnitude of p, 0.670. Now we are going to resolve the forces horizontally to untie the knot of this q, whether q is on the right direction or left direction. Okay, for that, this is now horizontal direction. So for horizontal direction, the concept is same. Driving force minus resistance to motion is equal to mass into acceleration. Okay, sorry, not mass into acceleration. Here, yes, it is mass into acceleration. Okay, now they have told that if q is on the right side, if q is positive, let's see what happens. Q is the first horizontal magnitude of force, then plus another one is also, look at this, p is our point. Okay, so from p we will, p is the reference frame. So right side to p is positive for x-axis and left side to p is negative. So the first triangle, this triangle is also on the right side of p, that's why it is positive. So it is going to be 5 cos, how much is the angle? Angle is 60 degree, cos 60 degree. Then this is the next, it is the direction is opposite to positive. So that's why it is going to be negative 10 cos 30 degree, cos 30 degree equal to, mass into acceleration is going to be 0 because resultant force is, now if we add up q to the resultant force or subtract q from the resultant force, it is going to be 0. So right side is 0. We are going to untie the knot whether q is on the positive direction or not. Okay, so it is going to be, q is going to be 10 cos 30. 10 cos 30 means, actually cos 30 is square root over 3 over 2. So 10 square root over 3 over 2 minus 5 cos 60 is half. So 5 over 2. Now if we use our calculator, q is going to be 5 square root over 3 minus 2.5. 5 square root over 3 minus 2.5. So our resultant force is 6.16. It is 6.16 if we round it up to three significant figures. Okay, 6.16 Newton. Now look at this. The twist was whether q is on the positive side or negative side. If you assume it to the negative side, what would happen? It would be, look at this, it will be 5 cos 60 minus, no, it is 10 cos 30, 10 cos 30 In that case, if q is on the right side, look at this, let me show you, then right side is only, what is it going to be? On the positive side is 5 cos 60, 5 cos 60 equal to, look at this, if q is on the left side, equal to q plus 10 cos 30, 10 cos 30. Okay, now let's see what happens. 5 cos 60 is 5 over 2, and 10 cos 30 is 10 square root over 3 over 2 is equal to q. Now look at this, what is it happening? 2.5 minus 5 square root over 3 is equal to q. That means q is going to be now negative. Look at this, 2.5 is less than 5 square root over 3. So q is getting negative 6.16 Newton. That's why this is the point to be noted. Look at this. If we use q, if we assume q is on the negative side, then the force will not be equilibrium. Look at this. It is not the resultant force which will make it equilibrium. That's why it shows that q is on the right side, I mean positive x direction. Q will be the positive x direction. Simply you will think that 2.5 minus 5 square root over 3 is the resultant force of this one. Okay, 5 square root over 3 is the resultant force of this one, so as this is larger, so definitely q should be on the other side, negative side is larger, so you will have to add up force on the right direction of x, otherwise it will not be equilibrium or equal. I think you got my points. As the negative force is already larger, force on the negative direction of x is already larger, so if you want to make it equilibrium, then on the right side of x, I mean right direction of x, you will have to add up the force. That's why we have added this q on the right side, okay, as driving force. I think you got my point, and thank you all for staying with me, and may Allah bless all of the human beings with beneficial knowledge. Allah Hafiz. Fi amanillah. Well, our today's topic is momentum. Means in most of the cases, momentum concept is applied for conservation of momentum. And the first question I have selected from paper 9709/43 for the session May June 25, and we are going to solve question number 1. We are going to solve question number 1 of this mentioned paper. Let's read question number 1. Two particles P and Q of masses zero point 0.1 kg and zero point 0.3 kg respectively are at rest on a smooth horizontal plane. P is projected directly towards Q with speed 4 meter per second. At the same instant, Q is projected directly towards P with speed u meter per second. After P and Q collide, P moves with speed 2 meter per second and Q moves with speed 4 meter per second. Find the two possible values of u. Well, from the question, one information is very distinct and clear, which is before the collision, P and Q are moving towards each other. That means their direction was different before the collision. But what happened after the collision? Nothing has been clarified about the direction after collision. So there will be actually four possible cases for the direction of the particles after collision. So before collision, it looks like, look at this, suppose this is P and another particle is Q. They are just moving towards each other. They are moving towards each other and they collided. So it is very sure that one of them will be negative. We can suppose anything to be negative because their direction was opposite to each other. So let's start writing our solution. So this is the first case. It may happen that after collision both the particles are moving to the same direction. That means both of them will be positive, either positive or negative, whatever. So let us write the concept of the conservation of momentum, and the formula for concept of the conservation of momentum is, mp into initial velocity of p plus, not plus, yes, it will be plus mass of particle p and initial velocity of, not particle p, it is particle q, and initial velocity of particle q, I mean uq. Okay, equal to mass of, as we are applying conservation of momentum, so mass of particle p and final velocity of p plus mass of particle q and final velocity of particle q after collision. Then we are going to substitute the values. We do have mass of particle p is zero point 0.1 and mass of particle q is zero point 0.3. So zero point 0.1 and initial velocity of particle p was u, sorry, it was 4u. For p it was 4u, and for q initial velocity before the collision what was u. So zero point 0.1 into 4u, as their direction is opposite to each other. Let's say q is directing negatively, so it is going to be mass is zero point 0.3 and velocity is velocity of q before collision is u. Then after collision, let us think both of them are moving positively. So mass of particle p is zero point 0.1 and after collision p is moving with 2 meter per second speed and q is moving with 4 meter per second. So it is 2 plus mass of particle q was zero point 0.3, which was moving with the speed of 4 meter per second. Let us calculate. So it is 4u and 3 minus 3u, that is 0.1u. 0.1u. And on the right side, if we calculate 2 ones are 2, 3 fours are 12. So 12 plus 2, that is 1.4. 1.4. Hence, if we divide 1.4 by zero point 0.1, it is going to be 14. U is equal to 14 meter per second. This is the first case, first value of u. So case number 2 is, it might happen that particle p was moving backward and q was moving forward. Okay, so that means we will apply the same concept, conservation of momentum. Let us write mp into initial velocity of particle p plus mass of particle q and initial velocity of particle q equal to, now direction has been changed as they are moving opposite to each other. Let p be negative. Okay, so mass of particle, not over here in the second step we can write. In this step it is just applying the formula mass of particle p into final velocity of particle p plus mass of particle q into final velocity of particle q after the collision. Well, then we are going to substitute the values. So before collision it is actually same as we have used here. We can copy 0.1 into 4u minus 0.3 into u equal to mass of, here look at this, we are supposing p is moving backward, that's why the negative symbol will be in front of p, which is 0.1 into 2 plus into 2 plus mass of particle q is zero point 0.3 and final velocity was 4 meter per second. So on the left side it is actually all the same, it is going to be 0.1 u. 0.1 u is equal to From 12, if we subtract 0.2, it is going to be actually 1. Okay. Now, if we divide 1 by 0.1, it is definitely 10. So, our second value of u is 10. Now, case number 3. So, is case number 3. Before the collision, their momentum will be same. Sum of the momentum. So, m p mass of particle p into initial velocity of p plus mass of particle q into initial velocity of particle q is equal to mass of particle p into final velocity of particle p plus mass of particle q into final velocity of particle q, and the initial velocity will remain same. We may use negative symbol in front of p also, but we are not doing, just for showing this actually. So it is left side is going to remain unchanged, 0.1 0.1 into 4u minus 0.3 u is equal to, now let q be negative. Okay, so p will remain as it is, 0.1 into 2 minus mass of particle q is 3 and final velocity was 4. So on the left side, what is it going to be? It's all the same. It is zero point 0.1 u. Zero point 0.1 u is equal to, here from 12, if we subtract 2, it is negative 1 point negative 1. Okay, hence u is going to be actually negative. Okay, our u is going to be negative how much? 10. Negative 10. Here there is a decimal point. It is left side is always same. So u is negative 10. Now if we go back to our question, look at this. In the question it is written speed is u meter per second. U was actually a scalar term which doesn't have any direction. Okay, so u cannot be negative, speed can never be negative, remember. That's why we are rejecting this value. Let us reject this. Okay, then the fourth possibility, if we use the fourth possibility also, we will find that u is negative. Okay, I believe that there is no necessity of explaining, I mean writing case 4. Case 4 will also be similar to the case 3. Actually, if we suppose both of them, after the collision both the particles p and q are negative, then it will show actually negative value of u. Negative value of u is rejected. So what are the possible cases? What are the possible values we can take? We can take the values of these, u is equal to 10 and u is equal to 14. So let us write here answer. So these are the two possible values of u, and the rest of the two values will be negative, which is rejected. I think you got my point. Now let's move on to the next question of the same topic. The next question has been selected from paper 9709/41 for the session May June 25, and the question says P is now projected on a smooth horizontal surface with speed v meter per second directly towards a particle Q of mass 1.25 kg which is stationary. After P and Q collide, the velocity of P is w meter per second and the velocity of Q is 2w meter per second. The loss of kinetic energy in the collision is 25 joule. Find the value of V and the value of W. As this is the part of question A, so we will have to pick up some values from A. From A, let me start the solution. From the previous solution, we have come to know that MP, that means mass of particle P is MP is equal to 0.5. 0.5. Well, 0.5 kg. That means mass of particle P is 0.5 kg. So let us apply, as this is the energy lost before and after collision. That's why we will have to apply the concept of the conservation of momentum. And the concept of the conservation of momentum, that mass of particle p multiplied by initial velocity of particle p means before the velocity before collision, and mass of particle q multiplied by initial velocity of particle q is equal to mass of particle p into final velocity of p. That means final velocity means the velocity after collision plus mass of particle q and final velocity of particle q. Okay, so mass of particle p is, we have already written, it is zero point 0.5, and initial velocity, I mean velocity before the collision, velocity of particle p before the collision, it was v meter per second, v, and mass of particle q is 1.25, which has a velocity of 0 because it was in stationary motion. So mass of particle p is now zero point 0.5, and after collision the velocity of particle p was w meter per second, so it is w plus mass of particle q was 1.25, 1.25, and final velocity after collision, final velocity of q after collision was 2w, 2w. If we simplify, it is going to be zero point 0.5, and this is 0 point 0.5b. zero point 0.5 into velocity is equal to, so 0 point 0.5, and it is going to be 2.5, so that is going to be 3w, 3w. So first of all we express v in terms of w, so v is going to be, hence v is going to be 6w, 6w meter per second. Okay, I think meter per second is unnecessary to be written because already it is written with each of the speed. Now for this we will have to apply the loss of kinetic energy, the concept of the loss of energy. Look, though this doesn't belong to our mentioned topic, but it is required to be applied for obtaining our values of v and w. That's why, so let's write loss of kinetic energy. Loss of kinetic energy, loss of energy is already given. How much is the energy lost? It is 25 joule. Here it is written 25 joule. So lost energy is 25 joule. Okay, now what is the formula for loss of energy? For loss of energy we know that is change in, it is negative definitely because energy was lost, change in kinetic energy of particle p minus change in kinetic energy of particle q is equal to 25. Okay, now the formula of change in kinetic energy is half mv square of which particle, particle p, minus half of mass into v square, that means final velocity of, not final velocity, this is actually difference between the initial and final velocity, equal to 25. Okay, now here, so let us substitute, this is more zero point 0.5 into mass of particle p was 0.5 into 0.5, and look, v square, in case of change in kinetic energy, it is actually difference between the final and initial velocities. V square doesn't mean that only final velocity. So final velocity of particle p was what? It is written final velocity was w square. Look at this, it is written here w meter per second, so it is w square, and initial velocity before the collision, it was Initial velocity of p was v meter per second, and v is what, 6w. So let us write 6w squared. Okay, so this is our first quantity. This is also this, minus the second one. For the second one, minus half, and mass of particle q is 1.25. Final velocity of particle q was 2w. Look at this, it is written here 2w, so we will write 2w square means 4w square. And initial velocity was actually 0 because particle q was in stationary mode. Now if you simplify, what is it going to be? Negative 0.25 into, it is no more negative. Look at this, 6 square is greater, so it is no more negative. So 0.25 and 36 minus 1, so it is actually 35w square. 35w square minus, this must be negative. Look at this, 1.25 means actually 5. If 5 is divided by 2, it is going to be 2.5. So 2.5 w square, and our right side is 25. It should not be forgotten, right side is 25. Let us write 25. If we simplify the left side, it is going to be 6.25 w square. 6.25 w square, and right side is going to be 25, as it is equal to 25. Hence our w is going to be, if we divide 25 by 6.25, it is going to be 4. Square root of 4 is going to be 2, and it must be positive because w was speed and it was positive speed. That's why our w is 2. Now we can write w is 2 when w is equal to 2, when we are supposed to find the value of v also. V is 6w. V is equal to 6 into 2 means 12. It is 12. So the value of v is, w was 2 meter per second. Let us write here w is 2 meter per second. One of the answer, though meter per second is not necessary to be written because unit is given with the quantity, and our value of v is 12 meter per second. So that's 2 are the answer we should found. We should find these two answers. Okay, w is equal to 2. They have told us to find the value of v as well as w. So v is 12 meter per second and w is 2 meter per second. Only 2, writing only 2 and 12 is sufficient. So I tried my level best to explain every part. I believe that you have understood my calculation. Our next topic is velocity time graph. And for the aforementioned topic, I have selected the first question from paper 9709/41 for the session May June 25. And we are going to solve question number 3 under this concept. Let's see what the question says. It says that diagram shows the velocity time graph of the motion of a cyclist. The graph consists of 3 straight line segments. The cyclist passes over a point O with speed 3 meter per second and then accelerates for 10 seconds with constant acceleration of 0.5 meter per second. He then travels at a constant speed for 30 seconds before decelerating, coming to rest at point P, covering a distance of 80 meters whilst decelerating. Find the total time taken for the journey from O to P. Well, this is what the question is, and we are going to find the total time. 40 minutes until 40 minutes it's given. Then we are going to find the final time instant when it came back to rest. So, for knowing the time, the final time instant when the particle or the cyclist came to zero is this point. We should know this timing, as well as we should know the velocity this point. Okay, this point should be obtained. So, for first part, I mean this V, we can easily apply this first segment. What is it written about? For the first segment, that means for first 10 seconds, it is written the particle was accelerates at the rate of zero point 0.5 meter per second for 10 seconds. So analyzing this information, we can find our velocity, and we know the formula, Shubert formula for velocity is v is equal to u plus a t. Okay, then we require v. Let us substitute the values. We do have initial velocity of the cyclist was 3, so let us write 3 plus, as it was accelerating at the rate of zero point 0.5 and the duration was 10 minutes, so zero point 0.5 into 10. Finally we have got that our velocity is going to be v is equal to 3 plus 50, so 3 plus 5, sorry, it is going to be 8. V is equal to 8 meter per second. Okay, so for the first 10 seconds the velocity was 8 meter per second, so hence we can write here 8. Well, so this point is also 8. Okay, then we will have to find that they have told that total distance. Look at this. When it was decelerating, the total distance traveled by this cyclist was 80 meter, and let us suppose it to be t, and the first part was for what was the time, 0 until 0 until how long? First 10 seconds. First 10 seconds. And then we will find for the last phase, for I think I can change the color of the stylus. It is for the second phase, I mean third phase. For 40, it starts from 40. So 40 until, let it be t. Let this moment be t, I mean uppercase t. The distance is written, the distance is equal to, distance traveled is equal to how long? It is written 80 meter per 80 meter. So let us write 80 over here. Then if we calculate this, we know the distance of this shaded region, area of the travel distance. So area of this is triangular part. So for triangular part, we will apply the formula of half into base. Base is actually t minus 40. T minus 40, and height is actually, this is height. Okay, so already we have found that this is 8. 8 is equal to 80. Well, then if this half multiplies 8, it is going to be 4. If 20 is divided by 4, it is going to be 20. If 8 is divided by 4, it is going to be 20. T minus 40 is equal to 20. Hence, finally, our T is going to be, T is 40 plus 20, it is 60. That means our final time when the cyclist came back to zero was 60 seconds. Okay, they have told us to find the value of t, so second needs not to be written, already it is with the quantity. So that's all about the solution to the first part of this question, and it's not difficult at all. It's one of the easiest questions of the aforementioned topic. Okay, they have told us to find the total time, so we can write one more step. So let it be written: total time is equal to total time is equal to 60 second. 60 second, let it be lowercase 60 second. Okay, that is what our final answer. Now let's see what the question number B says. Part B says, on the given axis, sketch a displacement time graph for the cyclist journey from O to P, showing on your graph the distance traveled after 10 seconds and 40 seconds. So they have given a velocity time graph, whereas we'll have to convert it into distance or displacement time graph. For that, as there are three different phases of the journey, so we'll have to find one after the other. Let's start with the first part. The first part was for 0 until 0 until 10 second. It was the first phase of the journey. Let us see what was until 0 until 10 seconds. The displacement was given s is equal to, we know we are going to apply the displacement formula because we should know what was the shape of the curve. Okay, because we cannot copy velocity time graph for displacement time graph, they are absolutely different from each other. So we should know actually how is the shape of the displacement curve or graph. S is equal to, our formula is ut plus half a t squared. Okay, then initial velocity, we are going to see the question again. This was the question. Look, initial velocity was for the first 10 seconds. Initial velocity, look, initial velocity was 3 and acceleration was 0.5. Initial velocity was 3, acceleration was 0.5, time was 10 seconds. So we can substitute these values. So our S is going to be S equal to, initial velocity was 3t plus acceleration was zero point 0.5. That means half into, again 0.5 means half t square. Actually we are going to know the shape of the graph, we don't need to find the value, exact value. Exact value is also necessary, displacement, but let us see the shape of the graph, because if we don't know the shape of the graph, whether this is straight line or curved line or quadratic or cubic function, then how will we start our drawing? That's why we are going to get, it is going to be 1 over 4 t square plus 1 over 4 t square plus 3t. So what will be the shape of this? This is actually quadratic graph and positive, and there is no, it must pass through 0 because there is no constant number. So this is going to be actually u shaped, that means positive graph starting from the first second quadrant. U shaped quadratic 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 curve. So we have got the shape of the first part for the first 10 seconds. Okay, then let us see, we require to know the displacement also. Okay, so displacement is equal to distance. Let us write here, distance is equal to Applying the same concept, we can find this initial velocity was 3 and time was 10 seconds. So 3 into 10 plus our half acceleration was also half, and time was 10 seconds. Time was 10 seconds. Applying the same concept, or you can find the total distance traveled in the first 10 seconds by applying the concept of the area of the triangle, because first not area of triangle, it was trapezium. So finally it is going to be 30 and here 125, so it is 55 meters. So for the first phase, we have found the expression of displacement as well as the distance traveled by the cyclist. This is the first part. Then the second phase. Let us see what was the second phase. The second part is this, actually this part. Okay, this part is actually a rectangular shape, and the this height is width is, we have already got it is 8, and then our this length is 10 to 40, that means 30. So 30 into 8, it is simply 30 into 8. So let us write for 10 until 40 seconds. For 10 until 40 seconds, as I have shown, it is just a rectangle. So this, first of all, we will have to form the expression S is equal to Vt. Okay, Vt, because there was a constant velocity and V was 8, so that is 80. Then what does it mean? It is simply a straight line. Okay, V is equal to S is equal to S is equal to Vt. That means this is a straight line which will, as there is no constant number, so it will also pass through the origin. So straight line, it is also a straight line. Straight line. Okay, then let us find the distance. Okay, distance is distance distance is distance. Applying the same concept, 8 into t was 10 into 40, it was 30, isn't it? It was 8 into time was, we have already written, for 10 until 40 seconds means 30 seconds. So it is equal, distance is equal to 830 is a 240 meters. 240 meters. Look, this 240 meters was the distance traveled in 30 seconds, but this is not the total distance until 40 seconds. So we will have to write the total distance. Total distance in 40 seconds. Total distance. Total distance means the previous distance should also be added. Total distance. Total distance is equal to, initially first there were 55 meters. Okay, now it has traveled to 40 meters, so it is total distance in first 40 seconds is going to be 295 meters. 295 meters is the distance traveled in the first 40 seconds. Then the third phase of the journey, we came to know from the previous graph that total time was 60 seconds when he was he came back to rest again. So for 60 seconds means 40 until now, 40 seconds until 60 seconds. Okay, 60 seconds. Let us see what is written about the final phase of the journey. It is written, look at this. For the final phase, for the final part of the journey, actually they didn't mention, look at this. He then travels at a constant speed for 30 seconds before decelerating, coming to rest at point P, covering a distance of 80 meters whilst decelerating. So distance is given, but they didn't mention the deceleration rate. So we will have to find first the deceleration of the final part. That's why we will have to apply the concept of V is equal to U plus 80. So V is equal to V equal to U plus AT. Okay. So final velocity he came to rest. So final velocity is 0. Initial velocity was 8 because from 8 it was coming downward, and acceleration is to be obtained and time was 20. Already we know that this is 20. Okay. So our A is going to be negative 8 over 20 meter per second square. 20 meter per second square. This is our acceleration. As we know the acceleration and time taken by the cyclist, we can find now S. Our S is equal to the same concept we are going to apply. S is equal to ut plus half a t squared. Okay. So displacement is going to be, initial velocity was 8 and time taken by the cyclist for coming to rest was 20, because 40 until 60 means 20, 20 plus half of it is negative because he was decelerating. Our A is having negative value, so minus half of acceleration was negative 8 over 20, 8 over 20, and our time was 20 squared. 20 squared. So how much is it going to be? For the final phase it was 160, and 400 divided by 1040. So 160 minus 80, it is going to be 80 meter. Okay. It is 80 from 160. If we subtract 80, it is going to be 80 meters. This is the distance traveled in the final phase, and we will have to find, let me rewrite it taking less space. So this 80 meter was the distance traveled in last 20 seconds, but what was the total distance? So let us write total distance. Total displacement, total distance is, initially we have found that in the first 40 seconds the distance was, in the first 40 seconds there was a distance traveled, it was 295, and in the next 20 seconds it was 80. So 295 plus 80, it is going to be 275 meters. 275 meter was the total distance. And now we are going to know the shape of this graph. So s equal to u. Initial velocity was 8t and acceleration due to gravity was negative. So negative, it is going to be half. A was 8 over 20, so for 1 over 5, 1 over 5 minus 1 over 5 t square. That means negative zero point 0.2 t square plus 8t. Okay, so what will be the shape of this? It will be, it is also a quadratic graph, but it is negative. So shape of the curve is going to be, it will be just negative graph starting from the third quadrant, and U shaped, that is n shaped, n-shaped quadratic graphs, quadratic curve. Okay, so quadratic graph. So we have got all three graphs. Now easily we can start our drawing. So first one was this U-shaped quadratic curve, and the second one was straight line. This one was straight line, and then the final one was U-shaped, that means negative quadratic curve. So let us start writing. For the first one, the time phases are first 10 seconds. Let us write the time, first horizontal axis 10, 40, and finally it is going to be 60. Until 40 they have already given, so let us write here 60. It is 60 when he came back. Well, now the displacement. So first displacement was, it was how long? 55 meters. So let us write here 55 along the vertical line. 55, let us see, first one was 55, second one will be 295, then finally it will be 275. So these three values should be written across the vertical line. Okay, that means displacement line. It's not 275, it should be actually 375 meters. So first of all, on top we are going to write 375. Our labeling has been done. Now we are going to draw the graph. Look at this. When the time was 10 seconds, then distance was 55. So let it be a point. Then when time was 40 seconds, distance was 295. Then when time was 60 seconds, our total distance was 375. Let it be over here. It is assumption. Remember, I am not writing using scale or any other measurement tool. So first one, look at this. First one is U-shaped. We have already written here. It is U-shaped quadratic graph through origin, because it will go through origin because there is no constant number. So how will it look like? It will look like this. Okay. Then for the second phase, it was straight line. Already we have written here. It is a straight line. So this will be the straight line. After that, finally, the final curve is also a quadratic curve, but it is negative. That means opposite to you. So it will look like this. Somewhat, it will look like this. And let me show you once again. So finally, your distance time graph will look like somewhat this. It may not be exactly accurate, but it will be somewhat similar to this. First part is third part has been first part has been drawn wrongly. Let me draw once again, because it was U-shaped. First part was U-shaped. Yes, the curve will look like this. First part is U-shaped, positive quadratic graph. Second one is straight line, and final one is again negative quadratic graph, which will start from the third quadrant. So this is how the curve will look like. Let me show you the previous part. The previous part was this. Okay, finding only the time, but it took much time to draw the curve, because drawing the curve on the display is really difficult on the drawing on the screen. Well, let's move on to the next question. The next question we are going to solve belongs to paper 9709/42 for the session May June 25. And we are solving question number 4. Let's read it. A car is traveling along a straight horizontal road. The car passes through a point A on the road traveling at a speed of 15 meter per second, and then accelerates uniformly at zero point 0.4 meter per second for 30 seconds. The car then moves at constant speed for 3t seconds, where t is less than 30. The car then decelerates uniformly at zero point 0.2 meter per second square, and after a further t seconds passes through a point B on the road. So there are actually three phases of this journey also. Question number 8 says, on the given axis, sketch a velocity time graph for the motion of the car between the points A and B. Well, as there are three turning points, I mean three phases of the total journey, initial velocity is given, it is 15. But when it was accelerating, we don't know the velocity at that time. So we will have to find the velocity for v is equal to when it was accelerating for 4.4 meter per second for 30 seconds. So let us find the velocity, because we are drawing velocity time graph. V is equal to u plus at. Okay, velocity is to be obtained of v is going to be u. Initial velocity was 15 and acceleration was 0.4, and time was 30 seconds. Hence our velocity is going to be 15 plus 12. 15 plus 12 is 27. So 27 meter per second is the velocity when it was accelerating. So let's mark the points. The time velocity was, first one was 15. 15, it started from origin at the speed of 15, and when it accelerated it was 27. So let us write here 27, 27, 27. Okay, and time was, first it was for 30 seconds. First one was, let it be 30 over here, 30. First phase was for 30 seconds, and it was traveling at constant speed for 3t seconds, 3t seconds. So here it may be 30 plus 3t, 30 plus 3t. Okay, then the car then decelerates uniformly at zero point 0.2 meter per second, and after a further t second passes through a point B on the road. Then for the final phase, the car then decelerates uniformly at zero point 0.2 meter per second, and after further t seconds. So there will be another t. So 30 plus t, again t, 30 plus 3t. It is not t actually, it should be 3t. 30 plus 3t. So let me write here 3t, 3t. Then again after t seconds, it was decelerating and passing through a point B. So 3t plus again 1t, so it is going to be 40. 30 plus 30 plus 40. It is 30 plus 4t. Okay. Then we are going to complete our diagram. Let me erase these unnecessary parts. So first 30 seconds, its acceleration was, velocity was 27. So let us write here 27, yes, at 30 seconds. Then it was moving at a constant speed until 30 plus 3 seconds, 30 plus 30 seconds. Then it continued until this point, that means decelerating. Okay, but we don't know exact velocity when it was decelerating. So how to draw this? We will just join this, because this was everywhere there was uniform acceleration or uniform velocity or uniform deceleration. That's why everyone will be a straight line. Remember, there should be no curve, because this was uniform acceleration, uniform velocity and uniform deceleration. That's why there is no scope of curved line. Please let it be noted that curved line is for ununiform. If there is variation in the velocity or acceleration, then there is curve. As this is uniform everywhere, look at this, the first phase was acceleration, uniform acceleration, and second one was constant speed, uniform speed, and the first phase is also uniform deceleration. That's why first phase will also be a straight line. Every three, all of this three part will be straight lines. Then as we don't know that when it has reached to zero, that means came back to rest, that's why it will be a dotted line, not solid line. We cannot, and you can even avoid this dotted line is not even necessary. Let me show you again. So this is our graph. So from here 30 to 30, this is going to be 3t, this portion is 3t, and from here this portion, if we connect these points, then the time span between this 30 plus 3t and 30 plus 40, this is actually t. Okay, now we are, this is what about the first part of the solutions. Then let's see B, what B says, question number B says the distance from A to B is 2750 meter. Find the value of T. So we know the distance is actually sum of the area traveled by the particle or cyclist or car, whatever. Then we will have to find the area of other part. Also there are actually three parts. So let us draw the other part. This is going to be over here. Okay, yes, this one. So we can start writing our solution as total distance. Total distance is total distance is equal to, as they have given, is 2750 meters. So for the first phase it is a trapezium. First one is a trapezium. So we will have to write the area of trapezium, which is, or area of trapezium is, half of this base is 30, and then the sum of the parallel lines, one line is 50, and the length of height of another one is 25, 27, 27. Okay, I think before starting our solution we should know the height of this distance. Okay, this height should be known to us. That's why we will have to find that height, the velocity at that moment when it was decelerating. For the first phase, it is already given. For we can write here for 0 until 10 seconds. For 0 until 30 seconds, our V is equal to 27 meter per second. Already we have collected this from the first part. Now for 30 plus 3t until 30 plus 40. Okay, for the third phase, for 30 plus 3t seconds until 30 plus 40. 30 plus 40, it is uppercase t actually, as they have mentioned. So V is equal to U plus A t. Okay, then our velocity was, final velocity is not known to us. Initial velocity is known to us. Initial is this height. This is known to us. It is 27. So 27, as this is decelerating, so symbol will be different, and deceleration rate is given here. Look, it was decelerating at 0.2 meter per second. So it is 0.2, 0.2, and then t is actually difference between 30 plus 40 and 30 plus 3t is, it's actually t, this uppercase t. So this is the velocity at the final stage, 27 minus 0.2 t. Now we can apply the concept of a superformula distance. So total distance is equal to total distance is equal to 2750 meter. So for the first phase it is, if we see carefully, we'll find the first phase is a trapezium. So trapezoidal area is half of our time is 30 seconds. So 30, and the summation of the parallel sides, one is 50 and the other one is 27. So 50 plus 27, 27, 50 plus 27, plus the second phase. Second is, it's a triangle, rectangle. So rectangle is base into height. Base is 30 plus 3t minus 30, so it is 3t, 3t, and our height is 27, 27. Now for the third phase. Okay, for the third phase, here we have already found that this is velocity is 27 minus point 2 t. Okay, so we are going to write this is also trapezoidal distance, that is half of the distance between these two. Look at this, 30 plus 3t and 30 plus 4t, it is actually just t. Okay, so t, then sum of the parallel sides, one is 27 minus point 2t, another was 27, so we will just write 27 plus. So this is how our step. Now if we simplify, it is going to be 20 27 plus 15, that is 42. 42 over 2 means 21. 21 into 30, that is 6300. It is going to be 630. 630 plus 327s are 81. 81 t uppercase t plus, here what is it going to be, 27 plus 27 means 54. 54 over 2 means 27, so 27t. 27t 27t minus, if we divide point 2 by 2, it is point 1. Point 1 t square. Point 1 t squared is equal to 2750. 2750. Now I will have to take some space to complete this. Equal to 2750 is our right hand side. Now if we simplify this, it is going to be 81 plus 27, that is 108t, and negative point 1 t square, negative point 1 t square plus 108t plus, it is not plus, from 2750, if we subtract 275, if we subtract 763 from 275, it is going to be 212. 212, then 0, it is going to be 0 right side. Now if we multiply every quantity by 10, it is going to be t square, and we are dissolving the negative symbol, t square plus, sorry, minus 10 minus 1080t plus 21200. Now if we break up the middle term, it may be t square minus 1060 minus 1060t t minus 20t plus 21200 equal to 0. Hence we can, if we factorize, it is going to be t minus 1060 into t minus 20 is equal to 0. Hence our t is 20. Now you may ask that how can we reject that t is, it is less than 30. I'm going to show you the part of this condition. Hence our t is 20. Answer is, they have told us to find the total t, the value of t, I think they have told us to find. So which is our answer? It is our answer. Let us see whether they have told us to find t or not. Yes, they have told us to find the value of t. Now why are we rejecting the value which is 1020? Look at this. Yes, it is distinctly written t must be less than 30. Okay, so our t acceptable value of t is just 20. This is t is equal to 20. That's all about this solution. Let me show you the previous question, previous solution again as a whole. This one. Okay, here we have got the we have drawn the velocity time graph. After that, we have found the value of t over here. Now let's see one more question. The next question has been selected from paper 9709/43 for the session May June 25, and we are solving question number 3, which belongs to our topic of velocity time graph. So let's see what it says. It says the diagram shows a velocity time graph which models the motion of a particle. The graph consists of three straight line segments. The velocity of the particle at time t second after passing a fixed point O is v meter per second. The particle leaves O with the velocity of 5 meter per second and accelerates at 0.75 meter per second square for 20 seconds. The particle then decelerates for the next 30 seconds at t equal to 40. The velocity of the particle is 0. After t is equal to 40, the particle starts to travel back to O, coming to rest at O at time t seconds. So from this graph, it's not complicated at all. First of all, they have told us to find the value of t. That means here, what is the time when the particle went back to 0. I mean, it came back to rest. Okay. So for first of all, what we should know that what is the velocity at this point when it was accelerating, and what is the velocity at this point when it was decelerating. Well, so for the first one, we can find applying the concept for the first. Let me erase this. For first 20 seconds, it is acceleration is uniform, so v is equal to u plus 80, and initial velocity is 5. It started from 5 meter per second, plus acceleration is given 0.75 meter per second square. So 0.75 meter per second square, 0.75 meter per second square into time is 20 seconds. So first velocity is going to be 5 plus 15 means 20 meter per second. 20 meter per second is the velocity at the first 20 seconds. Okay, so let us write here, it is going to be 20. Okay, now we should know this. This one, for this above this I can write here, for this is for first 20 seconds. Now for second 20 seconds, I mean for 40 seconds, we'll have to find the acceleration. For, let us write, for the time is 20 until 20 second until 40 seconds. 40 seconds. This is also a deceleration. We are going to apply the same concept. V is equal to u plus 80. So what is our velocity? We have got that velocity was 20. Let us see, velocity was 20. From 20 it was decelerating. So 20 equal to initial velocity, sorry, final velocity is 0, because when it was at this point final velocity was 0, so it is going to be 0 is equal to initial velocity was 20 plus acceleration is to be obtained. So a and t is, how much is t? T is from 20 until 40, it is 20 seconds. Hence our a is going to be, it is deceleration, so definitely it is negative. If we divide 20 by 20, it is negative 1. Okay, so our deceleration is negative 1, acceleration is negative 1. Hence we can find this point. Okay, so v is equal to, again v is equal to u plus 80. Okay, our velocity is to be obtained. Initial velocity is 0 and acceleration was negative. Time is how much? Acceleration is negative 1, we have just found 1, and time is 10 seconds. It took 10 seconds to reach this velocity, so it is 10. Hence our velocity is going to be negative 10. Negative 10. Okay, so now we can write here, it is actually negative 10. Negative 10. So we have got all of the information. Now easily we can find the value of t, and we are going to apply the concept of Subert formula, I mean distance formula. So distance traveled, look, once again let me clarify, you may get confused that how is the distance. Look at this, the particle was moving onward. the particle was moving onward and it has traveled a distance, suppose s, and as the particle is going back to origin, then definitely the distance it moved on and moved backward must be same. Okay, it started from here and again came back to this point. So the distance before, distance in the travel in first 40 seconds, in the last time means of t minus 40 seconds, it must be same because it went back to o. Let me show you, it is written, look at this, it coming to rest at o again. It started from o, look at this, a particle, it starts from fixed point o. It started from o and it came back to o. So definitely the distance is its travel in the first 40 seconds. I mean this area must be equal to this area. Okay, upper part contains two parts. One is trapezium, up to this it is trapezium, and second part is triangle, and lower part is only one triangle. So we are going to apply the concept that distance is going to be distance traveled, distance distance traveled distance traveled in first 40 seconds, traveled in first 40 seconds, first 40 seconds, 40 seconds must be equal to distance traveled in, distance traveled in, yes, I have written over here so that it's shows better. Then distance travel in first 40 seconds. In the first 40 seconds there are actually two shapes. One is, first one is trapezium, this one is trapezium, and second one is triangle. So first, for trapezium it is going to be, the area is half of, the time is 40 seconds, half of 40, and then sum of the, not 40 seconds, it is a trapezium covered 20 seconds I think, so it is going to be 20 actually. Let us write 20, it was 20. Then the sum of the parallel sides, first side is, this is 5 and this is 20, so it is 25, 25, 25, 25. Then the sum of the area of the triangle, I mean area of the triangle is half of our base is how much, base is 20 to 20, so it is 20, 20 to 40 means 20. Then height is same, it is 20, maximum velocity is the height 20, so 20 equal to right side. In the right side, distance traveled in the t minus 40. T minus 40 is this triangle. So this triangle is half of base is, height is already we have found, it is 10. Negative velocity was 10. And our base is t minus 40. T minus 40 seconds. Okay. So equal to, if we calculate this, it is going to be 250, and that is 400 up, so 450. It is 450 on the left side, and on the right side it is going to be, on the right side if we divide 10 by 2 it is 5. So 5t minus 400. Sorry, 540 is 200. It is 200. So 5t is equal to, if we, let me write over here, or 5t is not there, just let me write just beside this over here. So our 5t is equal to, 5t equal to, we have 450 plus 200, so it is 650. Then if we divide 650, 65 by 5, it's 13. So t is equal to 130. So our value of t is 130. Okay. Now let's see what V says. I mean, question number B says. Question number B says, here is B. Okay. So B says, find the acceleration of the particle from t until 40, t until uh, 130, t is equal to 30. So we can apply the concept, the simple concept. V equal to this is for B. Okay, for B, and our concept is B is equal to U plus A T. Okay, the final velocity is to be 0 because it came back to rest, and initial velocity was negative 10. Look at this, initial velocity was negative 10 and plus A, our A is to be obtained, and T is our, here T was 130. So from 130, if we subtract 40, it is going to be actually 90. So let it be 90 over here. Okay, then how will it look like? Let me change the ink actually so that it's distinct. So from it is actually t was 130, and they have told between 50 and 130, so it is 80. Hence our a is equal to 10 over 80. 10 over 80 means 1 over 8. Okay, if we divide 1 by 8, it is going to be a is equal to 0.125 meter per second square, so this is what the acceleration of the particle in the time between 50 and 130 seconds. So that's all about today's topic, velocity time graph, and I tried my level best to explain every tiny part. And thank you all for watching this part as well. Fi amanillah. Now we are moving on to kinematics, as you can see written on the display, and the first question has been selected under this topic kinematics is 9709/41 for the session May June 25, and as you can see it is question number 7, which is a particle x moves along a straight track starting from a point O at time t equal to 0. The displacement of x from O at time t second is s meter, where s equal to 3t raised to 3 over 2 minus 60. Find the time at which x is instantaneously raised, and hence find the total distance traveled by x between t equal to 0 and t equal to 16. Let's start our solution, and before solution I am going to erase these writings. There are two parts of this question. Number one is the particle was at rest. At rest means when a particle is at rest, then velocity is 0. So one of the time should be obtained when the velocity was at rest, I mean velocity was 0, and the second one is total distance. So first part of the question, s is given, displacement expression for displacement is given, which is s is equal to 3t raised to 3 over 2 minus 60. And for velocity, if we if we differentiate the displacement expression, then we will get our velocity. So let us find the derivative of this ds over dt in terms of time. If we differentiate displacement, it is going to be 3 over 2 into 3, and the power of t is getting decreased by 1, it is going to be half, minus it is going to be only 6. Well, then we can write v is equal to, hence our expression for v is, it is 9 over 2 means 4.5. We can write 4.5 square root over t minus 6. Then they have told that the particle was at rest. So we can write at rest. At rest our velocity is 0. That means 4.5 square root over t square root over t minus 6 equal to 0. Then directly we can find the value of t. What is it going to be? T is going to be t equal to 6 over 4.5, and for square root we will multiply both sides by 2 power 2 as power. Hence our time is going to be 16 over 9. 16 over 9 is the time when the velocity of the particle was 0. This is one of the answers. Okay, we can write here answer notation, because they have told us to find the time when the particle was at rest. Then the second part we'll have to find the distance. Then we are going to find the distance traveled by the particle between the time equal to t equal to 0 and 16. And for that it will be better for us to understand the nature of the curve. Let us draw the curve of this. It is so t second. And initially look at this. Initially for velocity time graph, let me write here v meter per second, v meter per second. Initially look at this. The velocity expression is this. So this is our velocity expression. Okay, and for velocity expression here it is 0. And initially we can see that when the particle started its journey, the velocity was negative 6. Negative 6 when t is equal to 0. Look at this. If you substitute t equal to 0, then velocity will be negative 6. So initially velocity was negative 6. Then at 16 over 9 points it was at 0. Suppose here there is 16 over 9. The time is 16 over 9, and we are going to find when the time was 16 seconds. So what was the nature of the curve? The curve was somewhat like this. Okay, it is a negative curve. Sorry, it's not a negative curve, it's a positive curve. It will look like this. Well, now according to this graph, if we look at this first phase of the particle is lying below the x-axis. From 0 until 16 over 9, the particle is moving below the x-axis. That means surely these velocity, this displacement, this distance is surely negative, because it is lying below the x-axis. And the second part is over here. Second part is this part is lying above. Let me change the ink. For the second part, it is lying above x-axis, so it must produce the positive value of area or displacement or distance, whatever you tell. Okay, so for the first phase it must be negative. That's why we will write already we do have the values, displacement expression, so there is no necessity of integrating this. Just we will write for just below this, we are going to write for the first phase. For 0 until when it was at rest, 16 over 9. 16 over 9, our displacement or distance expression is S1. You can write S1 as this is the first phase. S1 is equal to 3 into T. T raised to what? 3 until 2, and our time limit is from when to when? 0 until 16 over 9. Okay, 16 over 9 minus 60. So 60, and our time limit is 0 until 16 over 9. 16 over 9. Now if we simplify, it is going to be 3 into, let us write 16 over 9, 16 over 9, and our exponent is 3 over 2, 3 over 2 minus 6, and that is also 16 over 9. Okay, 16 over 9, but here we will have to write this minus 6 into 16 over 9, because look at this, as our lower limit is 0, so multiplying something by 0, it will also be 0. And finally our S1 is going to be, using our calculator we will find that. And remember, already we have explained that, already we have come to know that as this portion, the black portion, the first part is lying below x-axis, it will produce a negative value. So we will have to write a negative value or modular symbol. Whatever you do, you can do anything, but it must be negative. So this is negative value, hence it is also negative value. Okay, so finally if we use our negative symbol, it is going to be positive. This 96 over 96 over 96 over 9, then minus, it is going to be 3, then 27, so 9, it will be 64 over 9. 64, because 4 cube means 64, so 64 over 9. Then finally our first part of this displacement is 32 over 9. It is 32 over 9. So 32 over 9 meter is the displacement travel in the first phase when the particle was at rest, instantaneous rest. Then for the second phase, let me change the ink. Okay, we will write for for the second phase, our time is what? From 16 over 9, 16 over 9 until 16 second. Until 16 second. Well, let it be termed as S2, second phase or second part of the displacement. S2, and our expression is 3t raised to 3. So we will just substitute the values. 3 and t is going to be t raised to 3 over 2, and our limit is from 16 over 9 until 16, minus 6 into, then t, our limit is what? From 16 and 16 over 9 until 16. Okay, now if we substitute our values, we will get S2 is equal to, so 16 raised to, remember we don't need to put negative symbol at the beginning because it is already lying on the above x-axis. So it is 16 square root over 3 over 2 minus 16 over 9, and the power is 3 over 2, minus, outside that there will be 3, here there will be 3, then minus 6 into 16 minus 16 over 9. Finally, we are going to get S2 is equal to 3 into, it is going to be 16 raised to 3, means it is going to be, so 4 cube 64. 64 minus, this is going to be 64 over 27. 64 over 27 minus 6 into, it is 9 over 9 16, so 144. 144 minus 16, that is 128. We can easily write it 128. Well, after that, if we simplify more, it is going to be, after simplification using our calculator, we will get, it is going to be 896. 896 over 9. This is the second phase of the displacement. Now we will find the total distance. So the first distance was this 32 over 9, means this portion was the first distance, and second distance was this. So we can write total distance, distance equal to, we are just going to do addition. 8, this 2 should be added. So second phase is 896 over 9 plus 32 over 9. 32 over 9, and using our calculator we will find that our displacement is, if we round it up to three significant figures, it is going to be 103.1. So 103 meter is the total displacement. That is what the eh, that is what everything about the answer to the first question. It may look very clumsy because I don't have space to write either sidewise or downward. So that is the solution to part A. Let's see what B says. Question number B says, it says a second particle y moves along another straight track starting from a point P at time t equal to 0. The acceleration of y at time t second is a meter per second square, where a is equal to zero point 0.8 minus zero point 0.6 t. The velocity of y when it leaves P is 7.5 meter per second. When the velocity of y is negative 9.6 meter per second, show that the displacement of y from O is equal to the displacement of y from P. So for the particle B, particle y, the velocity is given but time has not been given. We should find the time, and at that same moment how much was the distance of particle x also. So first of all we'll have to find time, and before finding time we'll have to move back to velocity. They have given the expression for acceleration, so we can write ay, acceleration of particle y is equal to zero point 0.8 minus 0.6 t, and if we integrate we will get velocity, or we are integrating in terms of time, equal to, if we integrate 0.60 it is going to be zero point 0.3, because if we divide 0.6 by 2 it is going to be 0.3 t square, and it must be negative, plus zero point 0.8 t, zero point 0.8 t. So our velocity is negative 0.3 t square plus 0.8 t, or Vy, this is the velocity of particle y, or velocity of particle y is negative 0.3 t squared plus 0.8 t. That means it's a negative quadratic graph. Well, now look at this. We will, here we forgot to write something. The constant value should be written, because we don't know what was the initial velocity when it started. The initial velocity was 7.5. Hence, our velocity of particle y is negative 0.3 t squared plus 0.8 t plus 7.5. 7.5. Then they have told or plus c. Okay. Hence, remember this is a very crucial point. Whenever you integrate, you should know the velocity. I mean, at that time, particular time, what was the value of a velocity? Well, then they have told that the velocity was negative 9.6. So let us write v is equal to when v is equal to negative 9.6 when our expression is also equal to 9.6. When, let us write, the expression is negative 0.3 t squared plus 0.8 t plus 7.5 is equal to negative 9.6. After that, if we multiply everything by negative 10, it is going to be 3t squared minus 8t, and it is going to be negative, and that is positive, so it is going to be negative. So negative 96 minus 70, both of them will be actually now positive. No, it's negative. From 9.1, if we subtract, both of them will have to be added, because if point 9.6 is transposed to the left side, it will also be negative. So after doing addition, we have got it 96 75, that means 171. 171 is equal to 0. Now if we factorize, we will get 171 is 353. So 353 can be broken, split into 27 and 19, yes. So 27t plus 19t plus 19t plus 19t minus 171 is equal to 0. Now if we factorize, it is 3t can be taken common. So if 3t is taken common, it is t minus 9, and the second factor is going to be 3t plus 19 is equal to 0. Hence, as t cannot be negative, so our t is going to be t is equal to 9 second, since t is greater than 0. Okay. So at 9 second, the particle was moving at a negative velocity. Okay. Now we will have to find out the displacement it traveled in first 9 seconds. Okay. So before that, we must draw a graph of that. For let me change the ink. Let us draw a curve for this displacement. So this is velocity time graph. This is v meter per second, and this is t second. Okay. So the graph, look at this. At the beginning, initially, what was the velocity here? Look at this. They have told it 7.5 initially. So our expression was this one. This is our velocity expression. So for this one, for this expression, if we look, it's a quadratic graph, quadratic function, but it is negative. It starts with a negative coefficient, so it is negative quadratic graph. That means it is n shaped. Okay, n shaped. So initially the velocity was 7.5. Let it be 7.5 over here. So what will be the shape of curve? As this is n shaped, it will look like this, and we have come to know that it was just like this. Okay, and we don't know when the particle was at rest, and that is even unnecessary also. We will find until 9. Look at this. Here there is a huge twist. If we read the question, it says when the velocity of y is 9.6, show that we have already found that when the particle was at ninth second, then the velocity was negative 9.6. But they have told us to find the displacement. There is a difference, a very delicate difference between displacement and distance. In case of distance, we will have to find the total covered area, remember. But in displacement is only net distance, net change of position. Okay, so we don't need to add up in segment wise. There is no necessity of segment, so please don't get confused here. Look at this, sum of the part is above the graph, okay, above x-axis, and sum of the part is below x-axis. So you may ask the question that if we find displacement, first we will find the upper part and then the lower part. So it is unnecessary here, because displacement means only the net distance. So total distance, that means the balanced distance after positive negative, the resultant one is the displacement. So remember, if you are told to find distance, then individually you will have to find the upper part, then you will have to find the lower part, and they will have to add it up. But if it is displacement, that means you will have to find the net distance. That means the lower part should be subtracted from the upper part. That's why directly we can apply the integration formula. Okay, I think you got my point, that we are finding displacement, so there is no necessity of finding the distances individually segment wise. Just a net distance should be obtained. So for displacement, we will have to integrate the velocity. So for 0 until, let it be written, for our time is 0 until 9 seconds. Okay, then velocity of y is given as, velocity of y is negative 0.3 t squared plus 0.8 t plus 0.8 t plus 7.5 plus 7.5 plus 7.5. Or if we integrate this, v velocity is integrated in terms of time, then it is going to be, let us integrate this. So it is going to be 0.3 over 3. Let me zoom it out. If we integrate, it is going to be 3 divided by zero point 0.1. So negative 1, it is negative 1, then t cube, and our time limit is what? Time limit is going to be 0 until, our time limit is 0 until 9. 0 until 9 plus, if zero point 0.8 is divided by 2, it is going to be 0.4, and our function is t square. T square, and limit is from 0 until 9. 0 until 9 plus 7.5. 7.5 and 7.5 t. 7.5 t, and our limit, what is our limit? Limit is from 0 until 9. Then if we simplify, it is going to be, or our displacement, here also you can use this symbol. So our displacement of y is going to be, 9 cube means actually 729, so it is going to be negative 72.9, 72.9 plus 9 square means 81. If we divide, if we multiply 81 by zero point 0.4, it is going to be, let us write 32.4, 32.4, plus if we multiply 7.5 by 9, it is because lower limit is 0, so 75 9 equal to, it is 67.5, 67.5. So our displacement of particle y is going to be, if we add up these two and after subtraction we will get it is 27 meters. So particle y traveled 27 meters in the first 9 seconds. Now we should know what was the displacement of particle x at this 9 seconds. And our displacement expression for particle x is already given. Let us see what was it. It was s equal to 3t raised to 3 over 2 minus 6t. Okay, so we can just copy this expression for sx. Sx is equal to 3 and our time is 9. Okay, t raised to, okay, let it be 3t raised to 3 over 2. 3 over 2, 3 over 2, and time limit is 0 until 9. 0 until 9 minus 6t. Okay, so we will write here 60. 6, 6, then t. Let me zoom it out. Now, if we calculate this, or s, I mean displacement of x is going to be, so 9 raised to 3 over 2 is actually 3 cube means 27. 3 into 27 is 81. Okay, 81 minus 6 nines are 54. Okay, hence our sx, that means travel distance of particle x at 9 seconds is 27, which is equal to s of y. So they have told us to show and we have shown. Okay, now once again I am clarifying that you may think that in the previous part when we found the distance of particle x, we have used this. Look at this once again, let me show you. Here for finding displacement of x we have found in two phases. Okay, that is, one phase is this one. Here we have found first distance and the second distance was this. Okay, but in the final part, I mean in the solution to question number b, we didn't find that area or displacement individually because this was distance. Let me show you. Here they have told us to find the total distance. Look, here it is written total distance. It is about distance, whereas in question number b it is not distant at all. It is about displacement. So for displacement you will have to find only net distance. Okay, the negative distance is already subtracted from that one. That's why you don't need to find total distance and sum them up. It is simply you will have to integrate and the net distance will be found. And finally we have shown that when the particle y was at 9 seconds and the at 9 seconds the distance or displacement, net displacement of particle y as well as particle x is 27 meters. Thus we have shown that both of them have traveled the equal displacement. Let's see the next question. The next question is from paper 429709/42 for the session May June 25. Let me show you. The next question under the same topic has been selected from paper 9709/42 for the session May June 25. And it says a particle p moves in a straight line and passes through the point A at time t equal to 0. The velocity v meter per second of p at time t second is given by v equal to 2t plus 1 raised to 3 over 2 minus 2t square, where 0 until time is 0 until 3 seconds. Find the maximum velocity. So for maximum velocity, what do? We just find the derivative of velocity is 0. Actually, for maximum and minimum velocity, the acceleration is 0, means the derivative of velocity is 0. So let us find the derivative of the velocity. So our v is given, v is equal to 2t plus 1, 2t plus 1 raised to 3 over 2, 3 over 2 minus 2t squared. Now if we differentiate, the derivative is going to be dv over dt is equal to 0 for maximum. Okay, for maximum, let me write this. For maximum velocity, we know that derivative is 0. So dv over dt is going to be 0. If we differentiate this, it will be 3 over 2, 3 or 3 over 2 into, and the internal function has 2 as derivative, so it is 2. Then if we differentiate the function as a whole, that is 2t plus 1 raised to half. If we subtract 1 from the given exponent, then it is going to be 4t. Okay, and right side is our 0, so it is going to be 3 into 2t plus 1, that is square root of this, equal to 40. Now to remove this square root, we can multiply everything by square. I mean, we can square both sides, so it is going to be 9 into 2t plus 1, 2t plus 1 equal to 16t squared. Okay, so finally the expression is going to be 16t squared, or 16t squared minus 9 2s are 18t minus 9 1s are 9, and 9 16s are 144. So 26 and 4, 26 24 and 6, 16t square minus 26 24t 24t plus 6t minus 9 is equal to 0. If we factorize, then it is going to be, both of them are having 80 common, so 80 goes away, so it is 3t minus 4, 3t minus 4 and 8t plus 3. Hence our t is going to be actually 3 or 4 over 3. Sorry, we made a mistake. Let me erase this. If 8t is taken common, it is going to be 2t actually. So 2t minus 3 8s are 24, and again 8t plus 3 equal to 0. So our value of t is going to be, hence our t is going to be 3 over 2. 3 over 2. Since we cannot accept the value of t as negative, t is greater than 0 or equal to 0. So t is equal to 3 over 2. Now they have told us to find the velocity at this time. Okay, so let us write t is equal to, t equal to 3 over 2 when v is equal to, when v is equal to, let us write, our expression is this. This is the expression we have been given. 2t, that means 2 into 3 over 2 2t plus 1 and our exponent is 3 over 2 minus 2 into that is 3 over 2 whole square, 3 over 2 whole square, or our velocity is going to be here 2 to so 4 4 cube means, I mean 2 cube, 2 cube means 8, so it is 8 minus here 3 square means 9 and 2 square means 4, so 9 over 2, 9 over 2 is 4.5, 4.5, hence our velocity is going to be actually 3.5 meters, meter per second, when the time was 3 over 2 seconds. Let's see what the next one says. Question number B says, it is given that in the interval 0 until 3 seconds, the velocity of p is always positive. Find the distance of p from A at the instant when p is moving at this maximum velocity. So it's already positive, they have mentioned. So our velocity expression is v is equal to what? 2t 2t plus 1 raised to 3 over 2, 3 over 2 minus 2t square, and as we are finding for the distance, look at this, and it is already positive, so there is no necessity of drawing the curve, we will get it positive definitely. So if we integrate velocity, then we will get the v in terms of dt, and our time limit is 0 until 3 over 2, the time was 3 over 2. So let us write this. It is 0 until 3 over 2 and our function is 2t plus 1 raised to 3 over 2, then dt minus 2, and our time limit is 0 until 3 over 2 and it is t square in terms of t, or our displacement is going to be s is equal to now, first of all, if we increase this power, it is going to be 5 over 2, so 2 over 5, 2 over 5, 2 over 5, and if we integrate the internal function, this 2 will go down and our function is going to be now 2t plus 1 and 5 over 2, 5 over 2, 5 over 2, then our limit is 0 until 3 over 2 seconds minus 2, and here it is going to be 3 over 2 and t is actually cube, and our limit is 0 until 3 over 2 seconds, means 1.5 seconds. After that, s is equal to 1 over 5. 1 over 5 means actually 0.2. 0.2 into, now look at this, if we substitute here 2 into, so let me show through substitution, it is 2 into 3 over 2 plus 1 plus 1 and limit is 0 until 3 over 2 minus 2 over 3 into, as the lower limit is 0, so it is going to be 3 over 20, so 3 cube means 27 and 2 cube means 8, or our displacement is going to be 0.2 into, here lower limit is 0, so there is no necessity of counting lower limit, upper limit is 3 over 2, so it is 3 into 3 over 2, that means, but we skipped something, look at this here, The internal function has 5 over 2. So let it be written once again. Now, if we simplify more, it is going to be 3 plus 1, 4. 4 raised to this. So 2 raised to 5. 2 raised to 5 is, so it is going to be 4. 2 square means 4. 2 raised to 5 means 32. It is going to be 32 minus, it is 54 over 24. It is not 32, it should be 31 actually, because we'll have to subtract 1. If we subtract 1, then it is going to be 31. And finally, our displacement traveled by the particle is going to be 3.95 meter. And that is the answer to the part of this question as a whole. Okay. Let's see what the next question says. So the next question belongs to paper 9709/43 for the session May June 25, and we are solving question number 7. It says a particle x moves in a straight line. The displacement of x from O at time t second after leaving O is s meter, where the expression of s is given at this, and they have told us to find the velocity, and we know if we find the derivative of displacement we get the velocity. So s is equal to, let's write the expression 0.3 t squared, 0.3 t squared plus 0.6 t. So this is the expression for displacement. Now if we find the derivative of displacement in terms of t, it is going to be zero point 0.6 t then plus zero point 0.6. Okay, and they have told us to find t equal to 4. So t equal to 4 when t equal to 4, t equal to 4 when our v is going to be zero point 0.6 into 4 plus zero point 0.6. Okay, then it is going to be nothing but 3.00 meter per second, which is the answer to the simplest part of this solution. Then B says for t is greater than 4, the acceleration of x is at time t second after leaving O is a meter per second square, where a is equal to 0.3 t raised to half. There is no change in the velocity of x at t equal to 4. The velocity of x at t equal to uppercase t is equal to 14.2 meter per second. Find the value of t. So we will have to find the value of t. Let's see how to solve this. So here expression is given when for t is greater than 4 seconds. Our acceleration is given point acceleration is 0.3 t, 0.3 t raised to half. Now we should know the velocity first of all by doing integration. So a in terms of t, if we find the velocity, it is, if we integrate this, it is going to be 3 over 2. So zero point 0.3 into 2 over 3, and the exponent of t, the degree of t is going to be 3 over 2, 3 over 2, and we should not forget about the constant value at the beginning, or v is equal to so it is going to 0.1, 0.2 t raised to 3 over 2 plus c. Now we will have to find the constant value. It is written that t is equal to 4. They have told there is no change when t was 4. Look at this change in the velocity x equal to t equal to 4. So we can use t equal to 4 when our velocity was, our v was what? V was 3 meter per second. Already we have found here. Look at this. When v was 3 meter per second, t was 4. So let us substitute the values. V is equal to 3. So our v is what? 0.2 t is, it is 4. So 4 raised to 3 over 2 plus c equal to 3. Hence our c is going to be, so zero point 0.2 into 4 raised to 3 over 2. So our c is going to be, it is 1.6. If we subtract 1.6 from 3, it is going to 1.4. Hence our expression for velocity. Okay, so expression for velocity, hence our v is equal to, let me continue writing over here. Hence our v is equal to expression of v is 0.2t, 0.2t raised to 3 over 2 plus 1.4, not 1.1, it was 1.4, 1.4. C is equal to 1.4. Okay, this is our velocity. Then they have told us to find the velocity when time was t. Okay, so let me zoom it out. So it is written t is equal to uppercase T when our velocity is, our v is given 14.4. So let us substitute the values. Our velocity expression is 0.2 t 3 raised to, so instead of t we can write uppercase t raised to 3 over 2 plus 1.4 is equal to 14.2, or t raised to 3 over 2. If we subtract 1.4 from 14.2, it is going to be 12.8. So 12.8 over 12.8 over zero point 0.2. Hence our t is going to be, or t is equal to, if we divide this, it is going to be 64. So 64 raised to, it will be reverse reciprocal, so 3 over 2, 2 over 3. Okay, hence our t is actually 4 square. 4 square means 16. T is 16 seconds. 16 second, which is the final answer to this part of this question. Okay, let me show you whole of this solution. So we got the value of t as 16 second. Let's see what the next one says. The next question is over here, which says that find the total distance. This is again distance traveled by x between t equal to 0 and t equal to greater uppercase T, which is 16. Okay. Before we find the distance, let's draw the nature of the curve. Look at this. For the first phase, it starts from 0 and this is v meter per second, and that is time t second. Okay, now at the beginning, look at this, there are two phases. First phase was until first 4 second, and second phase was until 16 second. Well, so let us see what was the nature of the first one. First part was, look at this, for first 4 seconds it was, our velocity expression was this. Look at this, this was our velocity expression. Okay, so it is actually 0.60. That means it's a linear, positive linear graph. Okay, so it's a straight line. let's draw this straight line until 4 seconds. It will be until 4 seconds it is a straight line. And initial velocity, okay, we should know the initial velocity was 0.6. Let us write here 0.6. 0.6. So it was just a straight line like this. Then the next part, what about the next part? The next part is, next equation is, our velocity graph is this one. This is our velocity graph for the second phase. For the second phase, it is also positive, but it's a graph, not straight line. It's a curved line, but it is positive, which starts from 1.4. Okay, so let us draw this. It continues until 60 second. Okay, 16 second, and as it was positive, it will look like somewhat this, and we require until 16 seconds. Okay, so this one, first part is our straight line, then second part is a curve, positive curve. For the first 4 seconds, our displacement one, it was given already, expression was given by the question, which is point 0.3. Let us write for 0 until 4 second. Okay, for first 4 seconds they have already given, it was 0.3 into point, as lower limit is 0, so it is going to be 0.3 into 4 square, 4 square plus point six into t means 4. So our displacement is going to be, finally it is going to be 7.2 meters. 7.2 meters. Now the for the second phase, for 4 until 16 seconds. Okay, this is, we know the velocity, so we will find the, will integrate the velocity of v dt until 16 seconds. 16 second is equal to, if we integrate our velocity, our expression for velocity was 0.2, integrate it to t raised to 3 over 2, 3 over 2 dt plus 1.4, it was 1.4, then 1, it was 0 until 16 second, limit is 0 until 16 second, this dt. Okay, let me show you whether we have written correctly or not. From the previous page we can see, for the second phase, look at this, for the second phase it was, our velocity was this was the expression for velocity, that's why we have written 0.2 t raised to 3 over 2 plus 1.4 into 1. Okay, now if we simplify or substitute the values, it is going to be, this is our S2, let it be the second phase. So 0.2 and t, what will it be? It is given 3 over 2, that means 1.5, so it is going to be 2.5 over 2. So 5 over 2 will have to multiply by 2 over 5, and t is 5 over 2. Our limit is from 0 until 3 over 2 plus 1.4, and it is going to be t. Our limit is going to be 0 until 16. Well, or zero point 0.2 and 0.4, so it is 0.08. 0.08, then our time is 3 over 2 first one is 3 over 2. How many times? As lower limit is 0, so we can avoid multiplying by lower limit. It will also be 0. So into point, 3 over 2 raised to how many times? 5 over 2 plus 1.4 into lower limit is 0. That's why it is just upper limit. Hence our S2 second phase is going to be, let us use our calculator. We have been making a great mistake. It is not 0 until 16. It is actually, we are calculating for the second phase 4 until 16. So it is 4 until 16. If it is 4 until 16, it is going to be 0.08, 0.08, then 16 raised to 5 over 2, 5 over 2 minus 4 raised to 5 over 2, 5 over 2 plus it is 1.4. From 16, if 4 is subtracted, it is going to be 12. Then using our calculator we will get, that is, it is going to be 16, that is 4 square, 4 raised to 5, 512, and 2 raised to 5, 32. So totally we are going to get our 96.16. It is 96.16 is the displacement in the second phase. Here displacement and distance will be same because both the curve is lying above x-axis. Then we will have to find the total. They have told us to find total. Hence total distance is equal to total distance is equal to, first distance was 7.2 meters and second distance was 96.16 meter. If we add up, it is going to be 103.4. So if we round it up to three significant figures, it is going to be 103 meters. Okay, so that's all about the solution to question number second part of B. Let's see the final question under the same topic. The next question belongs to paper 9709/45 for the session May 25, and we are solving question number 6, which belongs to the same topic we are discussing today. It is, a particle P moves in a straight line starting from a point O. At time t second after leaving O, the velocity v meter per second of P is given by v is equal to 15 minus 2t whole squared. Find the values of t when the velocity of P is 100 meter per second. Well, so velocity is given. They have told v equal to what? They have told it is 100 meter per second. 100, okay, or v expression of v is 15 minus 2t whole squared is equal to 100, okay, or 15 minus 2t is equal to positive negative 10. Okay, now we require actually t, so t will have two values. Hence our t is, first value, if we add up 15 to 10, it is going to be 25. Okay, if both of them are having same symbol, then it's, so 25 over 2 is 2.5. And another one is, if 15 is having positive but 10 is negative, then it will be 5. So 5 over 2 is 2.5. First one is 2.5 and another one is 12.5. Well, both of them are acceptable because both of them are having positive symbol. Then the next question, immediate next one says, show that there is a particular value of t for which the velocity and acceleration of the particles are both 0. So v is equal to 0, first one. We are going to find v is equal to 0 first. V is equal to 0. So if v is equal to 0, our expression for velocity was what? 15 minus 2t whole squared. 2t whole square is equal to 0. Or our, if we expand this, it is going to be 225 or 4t square. 4t squared minus 30t plus 225 is equal to 0. Okay. So finally we will find that 15 minus 2 is equal to 0. Okay. So without expansion also we can write this. You may raise a question, what is the necessity of expansion of this? I will let you know later on, it is necessary, but it is simply what? It is 15 minus 2t into 15 minus 2t actually. Okay, 15 minus 2t is equal to 0. Hence, as both of them are having same value, it is t is equal to 7.5. But it is required later on. Well, this is for time when velocity is 0. Then for acceleration also it should be 0. Okay, let us find the acceleration. V is equal to V is equal to V is equal to what? 15 minus 2t. 15 minus 2t whole squared. Okay. Then for acceleration, we will find the derivative of velocity. dv over dt, it is going to be 2 and minus again 2. It is 15 minus 2t. 2t and it's equal to 0. Okay. Or negative 4 15s are 60. Negative 60 then plus 8t is equal to 0. Hence our t is same. It is 7.5. So we have found that in both cases time is 7.5 when velocity was 0. For t is equal to 7.5, velocity is 0, acceleration is 0. At the same time, when time was 7.5 seconds, then velocity was also 0. We have shown that it is shown. We can write here shown. They have told us show. So we have shown. After that, let's move on to the next solution. Next question is on the next page here. Find the displacement of p from O at the time that velocity and acceleration of the particle are both 0. That means t was 7.5. Okay. Before moving on to the displacement, we should draw the curve, as this is actually our curve should be shown. Look at this. This will be t second velocity time graph. It is 0 and that is v meter per second. Well, our expansion, I mean our expression was what for v? Our expression was this. That's why I told that this is necessary. Look, this was our expression. This one, look, this is now necessary. So it is just a quadratic graph. In quadratic curve, our initial velocity was 2 to 5. Okay, it is 2 to 5 and it is a u-shaped quadratic graph because this is positive. And look at this, when velocity was 0, our time was 7.5. At the same time, our acceleration was also 0 when t was 7.5. That means that is the turning point. So all this information should be inserted there. This is how will the curve look like. Look at this, at 7.5 the particle is at 0. At the same time, at 7.5 seconds the acceleration was also 0 because this is turning point. Well, now we'll have to find v is equal to 15 minus 15. 15 minus 2t whole square. Now we require the displacement, so s is equal to, we will have to integrate. If we integrate, it is going to be, should I show in terms of time? So if we integrate this, it is going to be first 1 over 3 degree will increase by 1, and negative 2 will go down. Then our function, inner function, is going to be 2t. Okay, then our displacement is going to, and our limit is from 0 until first 7.5 minutes, 7.5. So it is going to be s is equal to negative 1 over 6. If we use upper value, it is going to be actually 0. 7.52 are 15 minus 15, 0. So upper value is 0 into the lower value is positive. So what is going to be, if t is 7.5, so it is going to be 15 cube. That means minus 15 cube. 15 cube. Hence, our displacement is going to be, if we divide 15 cube by 6, it is going to be 562.5. 562.5 meter per second. You can round it up to 3 significant figures to write 563 meters. So that is what our final distance is. And that's all about the present topic. I mean, there is no more question left to be solved from this topic for the May June 25 session. And thank you all for watching this. Let's move on to the next topic. Well, now we are moving on to our next topic, tension and acceleration. And the first question under this topic has been selected from paper 9709/41 for the session May June 25. And we are going to solve the first question from this paper, which is number 6. Let's read the question. Two particles P and Q of masses 0.3 kg and 0.6 kg respectively are attached to the ends of a light inextensible string. The string passes over a smooth pulley fixed at a point B where the inclined planes AB and BC meet. P lies on the smooth plane AB, which is inclined at an angle of theta degree to the horizontal when sin theta is equal to zero point 0.4. Q lies on the plane BC which is inclined at 30 degree to the horizontal. The string is taut and the particles can move on lines of greatest slope of the two planes. The particles are released from rest. It is given that the plane BC is smooth. Find the tension in the string and the acceleration of Q. So from the question, we came to know that already plane AB is smooth given and BC is also smooth. So there is no normal reaction or frictional force at all, or simply weight is the force, weight and tension. So let us start our solution. Since there are two values to be obtained, one is tension, the other one is acceleration, there must be two simultaneous equations, and we resolve the forces applying the concept of the motion law of Newton. So let us start with P. Okay, this is P. So this is the system of P. Then we are going to apply the concept of the motion law of Newton. And the direction is P is just moving up like this. Driving force minus resistance to motion is mass into acceleration. Well, so driving force for P is nothing when the particles were released, so P is moving up. That's why tension is the driving force for P. Tension, and the resistance to motion is nothing but weight, because the surface is smooth in both cases. Both the surfaces are smooth. Mg sine theta. Mg sine theta is equal to mass of the particle P is zero point 0.3. So 0.3 A. 0.3 A. Then if we simplify, if you substitute the values, we will get tension is equal to mass of the particle is zero point 0.3, and acceleration due to gravity is 10, and sine theta is also given, which is zero point 0.4. zero point 0.4 plus zero point 0.3 into acceleration. Hence our tension is going to be this 1.2 plus 0.3 a. 1.2 plus zero point 0.3 a. Okay, we may leave this as equation number 1, as we know that there will be two simultaneous equations because two values should be obtained simultaneously. This is for P. We could have written here over P. Then for Q, let us write for the particle Q. For Q, Q is sliding down, so the direction is this, and we are going to apply the same concept of the motion law of Newton. Driving force minus resistance to motion is equal to mass into acceleration. Okay, and if we draw a system, then it will look like this. So for Q, nothing but the weight is causing Q move down. So we will write only weight is as driving force, or weight is mg sine 30 degree minus resistance to motion is nothing but the tension, equal to mass of particle Q is zero point 0.6 into acceleration. Well, then mass of particle Q is zero point 0.6, acceleration due to gravity is 10 into sine 30 is zero point 0.5 or half, minus zero point 0.6 A is equal to tension. We may leave this writing one more step. T is equal to 6 and zero point 0.5, that is 3. So 3 minus 0.6 A, 3 minus zero point 0.6 A. This is equation number 2. Now from equation 1 and 2, from equation 1 and 2, both of the right sides are tension, so they must be equal. If we if we do subtraction, then it is going to be, let me change the ink, it is going to be 1.2 or 3 minus, or 1.2, okay, 1.2 plus zero point 0.3a plus zero point 0.3a is equal to 3 minus 0.6a. If we simplify, it is going to be zero point 0.6 plus zero point 0.3, that is 0.9. So 0.9a is equal to 3 minus 12, that is 1.8. Hence our acceleration is actually 2 meter per second, 2 meter per second square. Hence we can find our tension. Hence tension is equal to 1.2 plus 1.2 plus 0.3a, point 3 into 2 equal to, it is going to 0.6, 1.8, 1.8 Newton. So these two are the answers to the question. One is acceleration and the other one is tension. That's all about the first solution. Let's see the next question under the same topic. The next question has been selected from paper 9709/42 for the session May June 25, and we are going to solve question number 5 following the same concept. The question is a little bit larger, which says one end of a light inextensible string is attached to a particle A of mass 3 kg. The other end of the string is attached to a particle B of mass 4 kg. Particle A is in contact with the raft plane inclined at 30 degree to the horizontal, and particle B is in contact with a smooth horizontal plane. A second light inextensible string is attached to B. The other end of this second string is attached to a particle C of mass 5 kg which hangs vertically. Both strings are taut and pass over small smooth pulleys that are fixed at the ends of the horizontal plane. The part of the string from A to the pulley is parallel to the line of greatest slope of the inclined plane, and A, B, C are in the same vertical plane. The system is released from rest. In the subsequent motion, C moves vertically downwards with acceleration 2 meter per second, and neither A nor B reach a pulley. Find the tension in each of the strings. So there are two tensions. One string is behind B, another one is in front of B, connected to B. So let us start our solution. We can start our solution with particle C, and for finding tension we apply the concept of the motion law of Newton. So for C, start with C. If we write C, C is just hanging downward. We will write for C, for as it is moving downward. So our concept is driving force minus resistance to motion is equal to mass into acceleration. Well, driving force is nothing but weight. Weight is mg sine 90 degree, or you can call cos 0 degree sine 90 degree, minus resistance to motion is the tension in the string BC. Tension in BC. Here there is a little twist. Mass into acceleration. You may think that both the strings are connected to C. So there should be tension in BC as well as tension in AB. There is a misconception in this case. Some students may get confused. Look, tension in AB, that means string AB is connected to BC. So all the forces, some of the forces, resultant force is acting on BC. So the tension in the string AB is also included in the tension BC. So it is just sufficient to write the tension BC, because all the forces, resistance forces is acting, including the tension force in string AB is also included in BC. So only it is about BC. That means AB plus BC in this case is equal to BC. So please don't get confused that why are we not writing tension in AB plus tension in BC. Actually, tension in the string BC is the sum of all forces. Well, then we can sum up, we can substitute the values. If we substitute the values, we will get mass of particle C is 5. So 5 into acceleration due to gravity is 10 into sin 90 is 1, which is unnecessary to be written, minus mass of particle C is 5. Acceleration is also given. Acceleration is given zero point 0.2, only 2, not 0.2. 2 is equal to tension in the string BC. Hence, tension in the string BC is going to be 50 minus 10 means 40 Newton. 40 Newton. 40 Newton. So, that is one of the answers. Now, we will find the tension acting or tension force in the string AB. Okay, this one. Well, so for AB, we will consider the particle P. So let us write for the particle B. For particle B, for particle B, B is actually, it is horizontally move onward. The concept is same always for finding tension and acceleration. We apply the concept of the motion law of Newton. So which is driving force minus resistance to motion is equal to mass into acceleration. Or driving force for particle P is tension in BC, because B is brought forward by the tension in the string BC. So tension in the string BC. Now resistance to motion is nothing but the tension in the string AB. At the same time, you may ask a question, why are we ignoring the weight? Actually, we are not ignoring weight. If we write weight is, or suppose weight is causing resistance to motion, in that case, it is going to be mg sine 0 degree or cos 90 degree. Cos 90 or sine 0, whatever you tell, sine 0 degree equal to mass into acceleration. Mass of particle B is 4 and acceleration is 2 meter per second. Hence, if we substitute the tension in particle, tension in the string BC is 40 minus tension in the string AB, and sin 0 is 0, so it is unnecessary to be written, which is 8 in the right side. Hence, our tension in the string AB is going to be nothing but 32 Newton. Okay, that is the final answer. So we have obtained both the tensions acting in each of the strings. So here just the twist is, don't consider that here BC plus AB should be written for the movement of C. All the tension forces, all the forces is now simultaneously acting on tension BC, string BC. That's why tension BC is a sum of all forces, negative forces or resistance forces for C. So let's talk about the next question. Let's see question number B. B says, find the coefficient of friction between A and the inclined plane. So frictional coefficient, that is different topic. We will discuss it in other question. Let us solve number C. B, question number B belongs to frictional coefficient, which doesn't belong to our present topic. It will be discussed in the under the other topic. So let us solve number C. C says, when the system has been in motion for 1.5 seconds, the string attached to A breaks. Okay. Find the total distance that A travels up the plane from the instant that the system is released from rest to the instant that A comes to instantaneous rest. Well, so let's start our solution. Since we skipped the solution to question number B, So some of the values should be extracted from B, which is frictional coefficient mu. Mu is equal to, frictional coefficient mu is 11 over 15, 11 over 15 square root over 3. No, I think this is not sufficient space. And normal reaction force R is equal to 15 square root over 3. These have been collected from solution number B. We can write here from B. From B, from B, solution to B, we have got this. Okay. Now we are going to find the displacement when the motion was 1 point, when the particles were in motion for 1.5 second. So there are actually two phases. Some distance has been traveled before the string breaks, and some distance has been traveled after the string breaks. First of all, we will start with before before the string breaks. Okay, before the string breaks, we are going to apply the Schubert formula because time has been given. V is equal to U plus AT. That means we require the final velocity. Initial velocity was 0 because the particles were released from rest, and acceleration was given 2, time is also given 1.5. That means at the time when the string breaks, the velocity of the particle was 3 meter per second. Okay, so at this time, how much distance was traveled, we can apply the Schubert formula. So first part of the displacement is S equal to ut plus half a t squared. Okay, so our first phase is initial velocity was 0, and our displacement, I mean acceleration was half of, acceleration was 2 meter per second, we know, and time was 1.5 second squared. Hence our first displacement before the string breaks is equal to 1.5 square, means 2.25 meters. 2.25 meters. This is the first part. Now we will find the displacement traveled by particle after the string breaks. Remember, whenever the string breaks, it doesn't mean that all on a sudden the particle was at instantaneous rest. No, the particle was still moving up to some extent. So at that moment, there must be an acceleration or deceleration. Let us find the acceleration just when the string breaks. After that, what was the acceleration? And for finding acceleration, we will have to apply the concept of the motion law of Newton. So it is about to slide down in this way to a little extent. So driving force minus resistance to motion is equal to mass into acceleration. Well, so what was the driving force? As there is no tension acting, that means there is no force moving it upward, so driving force is 0. But resistance force must be applicable. What are the resistance force? Look, the plane was rough. That's why first resistance was the frictional force, which is mu r. And the second resistance to motion was just weight, which is mg sine 30 degree, sine 30 degree equal to mass of the particle was 3 kg, so it's 3a. I mean point 0.3. No, not point 0.3, it's 3a. After that, we will substitute the values. Let me write just beside this. Or mass of particle A was 3. So it is, and mu, the value of mu is, already we have written here. This is the value of mu and this is the value of R, normal reaction force. So mu is negative 11 over 11 over 15 square root over 3. 15 square root over 3, and R is 11 over, I mean 15 square root over 3. R is 15 square root over 3 minus, that means force caused by weight. So mass of particle A was 3. Let us write 3 into acceleration due to gravity is 10, equal to acceleration is the mass of particle A is 3 and acceleration is to be obtained. So it is A. After simplification more, we will get 11 minus, both of them are negative, so it is going to be 30, 15, so 26, negative 26. So A is equal to negative 26 over 3. This is our acceleration of particle A when the string breaks up. Well, so using this acceleration, we can find the displacement after the string breaks. So we are going to apply the concept of Schubert formula. We know that V square is equal to V square equal to U square plus 2as. You know a formula, a relationship between velocity and displacement, and final velocity must be 0. Look at this, the particle A was moving like this. After, at one stage it got stopped and came to instantaneous rest, then it started moving downward again. Okay, so we require, when it was in the motion of 1.5, that means at this point, so at 1.5 second, suppose here it broke up, then this is the displacement made by particle A. Okay, so our final velocity is going to be 0 and initial velocity was 3. Actually we have already found here that initial velocity when the string breaks, it was 3 meter per second. So 3 square means 9, and acceleration is negative, which is 26 over 3, 26 over 3 and s. Now if we make s as subject, it is going to be negative 9 is equal to negative 52 over 3, 52 over 3 into s. Hence our s is going to be n 9 into 3 over 52. 52. Hence our displacement after the string breaks is going to be 27 over 52. So total distance, I think we can avoid this step. Let us write total distance. So for total distance, already we have seen that before the string breaks, the particle moved 2.25 meters, and after the string breaks, it traveled 27 over 52 meters. So total distance is going to be 2.25 plus 27 over 52 meters. So using our calculator, we find that total distance traveled by particle A is 2.77 meters. 2.77 meters. It is 2.77 meters. So that is the total distance traveled by particle A before and after the string breaks. So that's all about the solution to question number C. Let's find the next question under the same topic. The next question under the same topic has been selected from paper 9709/43 for the session May June 25, and we are going to solve question number 2, which says a van of mass 4500 kg is towing a trailer of mass 350 kg along a straight horizontal road. The van and the trailer are connected by a light rigid tow bar which is parallel to the road. There are resistance forces of X Newton on the van and 120 Newton on the trailer. The driving force produced by the van's engine is 2500 Newton. The tension in the tow bar is T Newton, and the acceleration of the van is 0.4 meter per second square. Find the value of X and the value of T. So there must be two simultaneous equations because we will have to find out two missing values. So first of all, start with the trailer. Okay. So for trailer, if we draw a diagram for both of the vehicles, it will look like this. So both the vehicles are moving on a horizontal road which is smooth. Okay, and the concept we are going to apply is driving force minus resistance to motion is equal to mass into acceleration. And as it is of the trailer, for trailer driving force is nothing but the tension. Tension is lying over here. This is tension is lying over here, Tn. So if we substitute the value driving force for the trailer is tension, because van is pulling the tension for pulling the van forward. So and resistance to motion is nothing but the weight. First of all, weight is what? Mg cos 90 degree, or you may tell sine 0 degree. Minus on the trailer there is one more frictional force. Look at this, 120 is the frictional force on trailer. Mass of trailer is 350 kg, so 350 A. Okay, oh sorry, acceleration is also given, so we can substitute. Acceleration is given 0.4, so we can write here 0.4. Then our tension is going to be, as cos 90 is 0, so weight doesn't have any force acting on this, so T is equal to 350 into 4, that is 120, plus it may be 140, sorry, 350 or 450. So if we multiply 350 by zero point 0.4, it is going to be 140. Hence tension in the string is going to be 260 Newton. That is the first part of the solution. Then for van, okay, for for when both of them are actually moving on the same horizontal track. So for when driving force minus resistance to motion is equal to mass into acceleration. Driving force is already given, so let us see how much is the driving force. Driving force is given as 2900 Newton. 2900. So let us substitute 2900 minus resistance to motion is the tension. And if you think that we are ignoring weight, we are not actually. So mg sine 0 degree, sine 0 degree or cos 90 degree. In the previous case we have used cos 90 degree. Cos 90 degree equal to mass into acceleration. So mass of the van is 4500 and acceleration is given as zero point 0.4 meter per second square. Now let us substitute the values, and we skipped actually the frictional force on van, okay, which is x. So let it be substituted over here. It is minus x resistance to motion, I mean frictional force, and the tension is also causing resistance to motion. Then our value is going to be 2900 minus tension has already been obtained, which is 260 Newton. 260 and cos 90 is 0, so there is no force due to weight. After that, if we multiply 4500 by zero point 0.4, it is going to be 1800, which will be subtraction 1800, and tension, I mean x, will go to the other side, frictional force. Hence our x is going to be from 2900. If we divide 2900 or 2500, I think it is 2500, not 2900. Driving force is actually 2500, not 2900. I made a mistake. It is 2500. So from 2500, if we subtract 2060, then it is going to be 440 Newton. 440 Newton is the frictional force on the van. 440 Newton. Look at this. This is 2500. So that is what the answer to the question, whole of this question. So that's all about this topic, and let's see our next topic.